Hello everyone, welcome to ZaranTech. In today's fast-paced digital world, businesses demand powerful solutions to manage vast amounts of data efficiently. Let's dive into SAP HANA 2.0. SAP HANA 2.0 is a revolutionary in-memory database platform that enables businesses to process massive volumes of data in real time, empowering them with unparalleled speed and agility. SAP HANA 2.0, with 32,000 plus global customers, revolutionizes data management. It offers up to 50% faster analytics and 60% lower TCO compared to traditional databases. Understanding it is vital for competitive businesses, boosting decision-making speed and improving customer experiences. Throughout this course, we will dive deep into the fundamentals of SAP HANA 2.0, covering topics such as its architecture, data modeling, administration, and advanced features. By the end, you will have the skills and knowledge to harness the full potential of SAP HANA 2.0 for your organization's success. But before we begin, please subscribe to our YouTube channel and hit the bell icon to receive regular updates from us. Agenda: 1. Evolution of SAP products. 2. SAP HANA Introduction. 3. SAP HANA Introduction and Deployment Strategy. 4. SAP Business Warehouse. 5. SAP HANA Database. Let's dive in.
Yes, this is the SAP HANA 2.0 training session. All right, so let's get started. Let me share my screen. We quickly looked at what are the different things that we are going to cover as part of SAP HANA's course. We talked broadly about the different categories of information that we will be covering. I broadly categorized them as 6 different sections. Today, what we're going to do is we're going to get started with the first section, which is called the SAP evolution, or I like to call it as the foundational building blocks. So let's start. Hope everybody can see my screen, my whiteboard. If you can you please give me a yes on the window, just to make sure that everybody can see it. So today what we're going to do is, as part of the first section, which is the foundational blocks, we are going to talk about the evolution of SAP. When I say SAP evolution, I'm going to give you an understanding of where did SAP start and what was the journey of SAP's different product portfolio, and how did we end up coming up to a product called as SAP HANA, and where we are today, and how the roadmap looks for the near future. So as I'm sure that many have heard the term SAP. SAP stands for Systems, Application, and Products in Data Processing. If you Google the term, this is the abbreviation. So SAP. That's what the naming convention stands for. But what we're going to be talking about is, so since we are starting off with SAP HANA, I'll first tell you, when SAP HANA started in 2010, the name HANA used to be an acronym. So HANA stands for, or stood for, High Performance Analytical Appliance. This used to be the acronym for SAP HANA. H, A, N, and A made it as SAP HANA, but we no longer use this as an acronym. SAP HANA has become so popular that it has just evolved into a product. It is no longer an acronym. Having said this, let's get an understanding of what SAP products were all about. Where did they start? What happened? And things like that. So to know that, you need to understand, let's go back maybe 3 decades and try to understand maybe 3-4 decades and understand how technology used to work in those days and how organizations were running their shops, right? So let's take a hypothetical scenario. Let's say that there is a company called XYZ. It's a car manufacturing company. It's a manufacturing company. Let's understand how things used to run in those days. I'm talking about the 1970s or 1960s. How the technology was enabling companies, big companies, to run their operations and what used to happen. So let's say that if I take any company, even today, it applies 4 decades ago. What we are talking about is, even though there could be several different departments within the organization, if I were to handpick a few very critical departments that helps run an organization, I can probably categorize them as, let's say, finance. Finance seems like an important part of any organization, right? Because at the end of the day, company wants to make money and manage their money. So finance is going to be a critical part of any organization. It could be a manufacturing industry, it could be an airline industry, it could be a hospitality industry. No matter what the industry is, finance is going to play a very critical role. Now that we are talking about a manufacturing company, I'm probably thinking that manufacturing is also going to play a significant role. Manufacturing team, the team which actually creates the product, right? They take the raw material and they convert it into a finished product. If there is going to be manufacturing, I am definitely going to have some kind of a sales team to help sell whatever has been manufactured by the company. So I'll say that there is also a sales department in the organization. And if I have finance team, if I have manufacturing team, and if I have sales team, I'm going to be employing people in all of these different departments. Then I probably need to manage the people also. So what's going to happen? I'm probably going to have a human resources department as well, because I have to make sure that the payroll is running, everybody is getting paid, and so on and so forth. So let's assume that these are probably some of the most critical departments an organization is going to have. Now let's take a quick scenario and understand what happens with this company on a day-to-day basis. Let's assume that this particular company has tied up with a vendor. There is some vendor who is providing some raw materials, because you need, for your manufacturing to start, you need some kind of raw material. The raw material is typically sent to your manufacturing plant. Let's say that this is your raw material. The vendor sends the manufacturing plant a set of raw material, and these manufacturing team, they go ahead and create the final product. Let's say in this case, the final product is a car. As soon as the manufacturing team creates the final product, taking the raw material and creates a final product, the manufacturing team lets the sales team know, we have created X amount of cars, go ahead and sell it to the customers. So the sales team, what they do, they reach out to different customers, and customers decide to buy the car. When they decide to buy the car, what happens is the transaction happens between the customer and the sales team, but the cash, the amount that is being paid, actually gets diverted to the finance team. So the dollar amount that a customer is paying is going to the finance team, and the finance team, what it does, it takes two sections. There is the revenue, that is the profit they made, and the expenses they have to cover. They take an amount of this money and they send it to the vendor, because if you remember, vendors were the ones who provided the raw material. So you have to pay them. So there is a dollar amount associated to pay with the vendor, and whatever revenue is generated gets trickled down to the entire department. So what happens? The revenue that has been generated gets sent to the human resource, because human resource has to start paying all the departments, because people are working. They have to start sending the information. Finance team has to provide the additional dollar amount to now invest in manufacturing more products within the company. So if you see that, there is a tightly integrated connection between all these different departments. They work hand in hand to create a product. So for creating this car, in this particular example, manufacturing team has to work with sales department has to work with finance department has to work with human resources department. This is what happens at a very, very high level in any organization. There is a tight integration that needs to be performed between different departments in an organization. Now, how did this integration happen? In those days, I'm talking about the 1960s and the 1970s. How did organization make sure that the communication between the finance department and the manufacturing department and sales and human resource was happening well? In those days, what used to happen is, let's assume that finance team used to run all their information through, let's just to give you a hypothetical example, right? They are running everything using a Java application. This is just a hypothetical. Maybe Java did not exist at that point, right? But just to give you a picture of what used to happen. All finance related information was maintained in a separate application. Let's assume it was Java. All manufacturing related information, let's say, was supported by another application. Let's assume that was .NET application. All manufacturing. All sales probably was being supported by, let's assume, some CRM application. I'm just giving you examples of the idea behind what I'm explaining here is each department acted as silo or individual organization, and they were running their own applications. And let's say human resources was running it through, let's assume, PeopleSoft or some application. Now, if each of the department was containing its own application and they were running individually, imagine in those days, how did the interaction happen? If something happened in my finance team, how does the finance team know the data from finance has now been fed to manufacturing? The data from finance has been fed to sales, and the data from information has been gone to. Because now these are all individual applications. In those days, you had to manually make the integration or the interaction between these. So what was becoming a big challenge is integration. How do I effectively send the information from a finance application to my manufacturing application, and from manufacturing to human resource and sales, and vice versa? So integration between the systems within an organization was an extremely big challenge. So this was one of the challenge. The second challenge was, were they able to confirm that whatever information has been shared between these applications were still accurate? Because one technology is talking to another technology. There is high possibility that when the data transfers from one application to the other, there is a possibility for data corruption. A data can get missed, it can fall through the cracks when it is moving from one application to the other, or it can even get misinterpreted. So there is whole possibility of data inaccuracy, right? So when you look at it, the common challenge that was happening in those days was that there is no integration, proper integration, and there is no data accuracy. So imagine organizations, what used to happen is, this is what the biggest challenge was. So at that point of time in 1972, 5 IBM employees, when they were working on all these big projects, they understood that, hey, there is a big challenge that's happening within an organization where I'm not able to integrate information coming from one department to the other. If you look at it, they said, this is nothing but for an entire enterprise. There are resources being allocated for finance, there is resources being allocated for sales, there is resources being allocated for human resources. How do I effectively plan and combine them in a proper manner? And that is how the term coin, enterprise resource planning came into play. So they looked at this problem holistically, and they understood that integrating or making all these different parts of your enterprise work together, there is a big challenge. So that is how the terminology called as enterprise resource planning came into picture. So now what it means is, you see that the enterprise is nothing but your XYZ organization. The different resources are nothing but your different technologies that are supporting the different parts of your organization. And how do I effectively integrate or plan or bring them together to work like a machine? So that is how this term called as ERP, Enterprise Resource Planning. The acronym for that is ERP. That's how they came up with this terminology. So when these 5 IBM employees looked at this as an opportunity, they said that, okay, we are going to start our own company and maybe start helping with ERP solutions. So in the market, two major companies evolved. Two companies came into existence to support enterprise resource planning as a solution. The first company is SAP, and the other company is Oracle. So I'm sure that people are familiar with these two different products. These were the only two ERP systems or companies that can support ERP as a solution. But the approach taken by SAP and Oracle was a slightly little different. If you look at Oracle, Oracle said, okay, this being the problem, if you look at this organization structure here, if I were to pick out of these four different departments, let's say finance, manufacturing, sales, and human resource, if I were to pick one particular functionality or one particular department that is more critical than anything else, and they identified that finance seems to be the heart and soul of any organization, they said, because we think finance is very, very critical, we are going to create an ERP solution which is going to focus on financial aspect of any organization. So what happens is, whether there is different departments, there is sales, there is human resource, there is manufacturing, so on and so forth. Oracle said, what I'm going to do is, I am going to be focused on how each of the different departments within the organization are feeding data into my finance department. Their focus was how data gets fed into the finance department from different departments. Their focus was mainly on maintaining how effectively I can keep track of my other departments integrating with finance department. So they focused mainly on what happens, what is going out of my finance team and what is coming into my finance department. That was becoming the main focus of Oracle system. So that's why you would hear the term Oracle Financials. The ERP system created by Oracle is called as Oracle Financial because they created a niche product which is mainly focused on looking at how the financial data is being managed. On the contrary, SAP took a more generic look at the ERP solution. They said, I understand that finance is a very critical part of the organization, but so are the other departments within the organization. I'm not going to just focus on one particular product. I'm going to be focused on integrating the entire departments within the organization. So they created a product which broadly focuses on three major subsections of an organization. So they said, obviously, I'm going to focus on finance because finance is very critical. I'm also going to broadly look at logistics. So if I say finance, finance can contain accounts payable, accounts receivable, general ledger, investment management, so on and so forth, that could contain many sub-information about finance. Logistics on the same way can have sales and distribution, can have material management, can have production planning, can have plant maintenance. And then finally, they have human resources. So the ERP solution created by SAP broadly categorized its system into three major buckets. It said, I can support anything to do with finance. I can support anything to do with logistics. I can support anything to do with human resources. If you look at human resources, payroll, time and administration, budget, and so on and so forth. So what SAP did is they went and created a product which is much more broader in perspective, and it can be applied to any organization. Oracle Financials, on the other end, though it is a very good product, it started only focusing on finance as an option. They said, I'm not going to care about what is happening internally within sales. I'm not going to focus on what's going to happen internally within your human resources. I don't care about your how you hire people, how you fire people, how you plan for your next hires for the next year, and so on and so forth. As long as there is a financial aspect associated with it, and it's going to make a difference in your finance department, I'm going to only focus on that aspect of your organization. So when you look at these two broad categories of ERP solution, naturally you can see that the reach of SAP is much significant than where Oracle would be, right? If you look at the market share, SAP now typically has about 70 to 70% of the world market when it comes to ERP solution. And it used to be 70-30, but this 30 is now being shared by many other companies. There are now many other softwares, ERP softwares that are available that are competing. But you can see that SAP is still the market leader when it comes to providing enterprise resource planning solution. So I'll take a quick pause here. Does this information make sense? The reason I'm talking about this is you need to understand where did SAP even start and what was the reasoning for it to start, right? You hope everybody can appreciate where it all originated. All right. So perfect. So with this information being available, now let's look at the product evolution of SAP. So now we can understand that SAP as a company started in 1972 by 5 ex-IBM employees. They started this company called SAP, and they started, what was the first product they brought into the market? It's called SAP ERP. See, the term ERP became only lately available. It was not when they brought this company made this company called SAP. They did not have this naming convention called as enterprise resource planning. Even though that is what the concept is, they did not know to call it ERP at that point. So the product that they've developed, the very first product that SAP company came or brought into the market to solve this enterprise resource planning issue is called SAP R1. That was the very first product from about 1972 to 1978 or so. This is the product that was being sold in the market by these 5 employees, ex-employees of IBM, who started this company called as SAP. So what is this naming convention? What R1 stands for? So one of the challenges when we looked at, what are the 2 challenges that we looked at when having to run any enterprise resource planning in an organization? One is integration and data accuracy, right? So they saw that integration is very critical, and especially when you have departments like finance, sales, manufacturing, human resources. One is you have to make sure the integration between these departments is intact, and preferably it is live or real time, which means that if something happens in the finance department, it doesn't make sense for the sales department to know it 3 days later. You need to know it almost right away so that sales can make an information, a sound decision based on that information, right? Would everybody agree? So not only integration and accuracy is important, that real-time integration is critical for the organization to be able to provide value add both to the company itself and to its customer. So the naming convention R1, R stands for real-time integration. They understood what the problem was with the companies at that time, and they created this product and said the naming convention was R means it is real-time integration, and 1, at that it tells me how many layers does this application have. This product called as SAP ERP or the R1 system, how many layers does it have? 1 refers to it's a 1 tier or 1 layer architecture. Now, what is a 1 layer architecture? If you go back in time, if you're familiar with what used to happen in those days in the 1960s and the 1970s, everything was being run by a single box called as mainframe. Everything was run on a mainframe system. So this one box is the 1 layer. Your SAP system or application was run inside a 1 layer box called as mainframe. Because it was supported inside a 1 layer system called mainframe, the term was referred to as 1 tier architecture. So it is being supported by 1 tier called as mainframe. Inside that mainframe box is where the SAP application used to run in those days. And in those days, mainframe was very popular. That was the only possible solution available. So everybody went with this particular route. But slowly, people started realizing that mainframe was becoming more and more obsolete, and they wanted to get rid of that technology. And people wanted to move with more updated and latest and greatest versions of SAP system. So what happened? SAP also started evolving. By around 1978 till about 1990 or so, they moved into the next generation ERP system, which is called R2. Again, R stands for real time. Now the two here means that it's a two-tier or two-layer architecture. So what were the two layers that was supporting this is, we got rid of the mainframe and we went into a server architecture, server-based system. So now what happened is, one of the layer was, they created a separate layer for storing your database. All the data will reside inside this database, and you will have an application layer where this is where the software is going to, software which is nothing but your SAP software is going to reside. Now they moved from a mainframe system to a server-based architecture. Layer 1 is your database layer. Layer 2 is your application layer. So that's why it is called it was called a two-tier architecture. But the problem here is, even though it is better than your mainframe, you moved from an older technology to a newer technology. The issue is, just looking at this picture, if you look at it, even though my application and my database are two separate objects, if my server goes down, it's shut down, or there is a power outage or something happens to the server, can either one of the application or the database survive? Can they still be up and running? If you see, if you think about it, right? If the server itself is down, can the underlying application and database be supported at that time? No, right? Because if the main box itself is switched off, the application and the database also will get switched off along with that option. So that was the disadvantage with this particular approach. Even though two-tier architecture is better than the old obsolete mainframe technology, there was still opportunity for SAP to grow and evolve its product. So in the 1990s and going forward, SAP went with the next evolution of technology, which is R3. R again for real-time integration. 3 is the three-tier architecture. The 3 tiers of the architectures were, or it's still applicable now, they created a separate box for a database independent of itself. This is where all your data is stored in tables. You have a separate box which contains an application layer. This is where your software, your SAP software, is going to be residing. And you have a client to access the system. So they can integrate with each other, but they are individual boxes, which means that if something goes wrong with my database layer, the application is still running. The only problem is it cannot probably store data inside your database, but people can still, if they are going to be doing reporting on this system, they can continue to do it, and vice versa. So this is the first layer, this is the second layer, and this is the third layer. The third layer, this is called client server architecture. Client, in our current world, if you want to relate this to some information, think of this as your, let's say you want to access your Gmail email account, right? Gmail is a software. So imagine that your Gmail is residing in the application layer. Whatever emails that you have within your Gmail software are data. So they are going to be, the emails are going to be stored in a database that is in a separate database system. But to access your Gmail account, do you go to, let's assume that this particular server, the application and the database for the Google Gmail product is probably in some part of California, let's assume. Every time to access your Gmail, are you going to go take a flight to California, go look at the server and understand what my emails are? Or do you simply use a web browser and get connected to this system. This system can exist anywhere in the world. It doesn't matter. As long as you have a web browser and you have internet connection, you just connect to that application and you're able to access your email. Does that make sense for everybody? So this is what the client server architecture is, and this is the current architecture that SAP uses. So SAP currently goes with all the products that it has created so far are now based on this three-tier architecture, client server architecture. It has three layers. The client layer. So the application can reside in, let's say, India. The database can reside in Japan, for example. It doesn't matter. For me as a user, all I need is a browser or a client. I can connect to the application which is in India. I can connect to the database and pass the data to that database which is residing in Japan. So that is what is called a client server architecture. So SAP said once they got to this R3 architecture, they said this is perfectly fine. This is the correct architecture that we want to use. And going forward, even though the naming convention kept changing from R1 to R2 to R3, it eventually became SAP ERP, which is Enterprise Resource Planning. And now it has become S4 HANA. So you might ask me, what does this 4 mean here? It's nothing but because if you look at the naming convention, the first product started with a 1, the second product went to a 2-layer architecture, went to a 3-layer architecture. Even though the latest product is in a 3-tier architecture, because they have evolved the product to a next level, they gave it the naming convention 4. The architecture is still the same. It is still a 3-tier architecture because now it is a different ERP solution than what used to be in the past. That's why they have given it a naming convention as S4. Okay. So that is how the product numbering also evolved in the market. Are we understanding how the product evolved within SAP and why did the naming convention came into existence as R1, R2, R3 and into S4 eventually? Well, if that is clear for everyone, let's now understand the details of that product evolution. So let's take SAP product evolution. Just naming it from R1 to R2 to R3 is not going to make a big difference. What we need is to understand where did they start, what was the issue with the product, and what did they do to make it better and evolve into a next product. So let's try to broadly categorize the SAP evolution into 3 major sections of eras. So I will say the first is beginning from 1972 to, let's say, 1980s, or I can even say 1980s till about late 1980s. We will say this is one of the era. The next era is 1919 to early 2000 and 2000 going forward. If I can broadly categorize SAP's evolution in these 3 different periods of time, let's understand what happened. So we all now understand SAP went and created this product. If I were to generally coin them, an ERP solution, right? What is this ERP solution? This ERP solution broadly was supporting information about 3 major functionalities within any organization. One is finance, logistics, and human resources. These are the 3 major functionalities that was being supported by SAP, right? So when SAP came up with this ERP solution, for each of this, let's assume that let's call these as modules. It's a finance module, it's a logistics module, and it's a human resource module. Each module had sub-applications within them. So there was an application that was supporting accounts payable, because accounts payable within a finance department, if you're not familiar with the financial terms, accounts payable is nothing but anything to do with expenses. For a company, if I have to pay rent for somebody, if I have to pay money for buying raw material, any money that I am spending to keeping the organization running, those are expenses. All your expenses are going to be tracked in something called as accounts payable. That's where all within your finance module, a sub part of your finance module is called accounts payable, which keeps track of all your expenses. Then you have accounts receivable, all revenue related information, all the profits I make, all the uh, uh, benefits I am making, anything that is to do with profit and revenue is going to be tracked with your accounts receivable. The general accounting information is going to be maintained within your general ledger. So there are several. So when SAP created this product called SAP ERP, the finance module contained several such small applications within them. Similarly, logistics focused on sales and distribution. How do I sell a product and how do I send it out? How do I distribute that to the different customers within the company's portfolio? And that they came up with material management. How do I take raw material and convert it into a final product? The complete life cycle of a material management, from raw material, how does it go to a finished product? How do I maintain the plant to do the manufacturing? If I were to convert a raw material to finished product, I need to establish a plant or a factory which can help me automate the process of moving from raw material to finished product. And so there were several sub applications within this logistics module. And similarly, within human resources as well, you will see that there was payroll, because I need to pay the people working within the organization. I need to make sure that I'm capturing the vacation and uh, time management. How many people are checking in at what time, checking out at what time? All that information needs to be kept. And budget, I need to plan for next year's expenses also. So if you look at it, when the SAP ERP solution was created, these were some of the different applications that was being supported by the organization. Now, think about it very simply. In those days, what was the main reason to maintain this particular system? Would it be fair to say, I want to know, as an organization, at any point, I want to know what is happening within the finance team, what is happening within the logistics team, and what is happening within my human resources team? So if I were to oversimplify, at the end of the day, what was the benefit of having an ERP solution for an organization is for me to know day-to-day reporting. Would everybody agree with me? So what I'm saying about day-to-day reporting is, today I want to know how much money did I have at the start of the day. After selling how many products, how much money do I have left, so that I can plan for my tomorrow. If you look at it, this can also be considered as operational reporting. Nothing fancy about this reporting. I want to know how much money did I start with, how much money did I end up at the end of the day. Do I have enough money to run tomorrow or maybe day after tomorrow as well? The focus in those time, 1970s to 1980s, was mainly focused on how can I run my day-to-day operation. In order to run my day-to-day operation, what information would I need from my finance team? What information would I need from my logistics team and from my human resources team? It was very narrow focused, and it was serving a purpose. Because if you also remember, we are talking of before pre-internet era. People, if I had a company called XYZ in, let's say, in Detroit, Michigan, my competitor probably is going to be another company in the same neighborhood, maybe within Detroit or maybe within Michigan for the most part of it, right? Most of my competition is going to be my neighbors. I'm going to compete with them. So in order to compete with an organization, all I need is to know basic information about my day-to-day operations. That was sufficient enough at that point to run a healthy company. If I knew how much capital I had for tomorrow, I can probably beat my neighboring company and know how to get the market allocation in a better way. That was the main focus then. So what was not available at that point, if I were to, let's say, no analytical reporting concept was available. What I mean by analytical reporting is there was no focus on, can I plan for the next 6 months? Can I plan for the next year? Can I do forecasting? Can I do trend analysis? These concepts were not available at that point of time. The idea of doing more than a day-to-day operational informational reporting, there was no need for me to go over and beyond and look at information beyond that. But that started slowly changing when we moved on to the next era, which is 1990s. What happened? We moved into something called as the globalization era. We are talking now, internet had started. Companies were not just competing with their next door neighbors. Now the competition became much more worldwide. A company in US could be competing with a company in China or with a company in India. And now it became even more difficult for you to do competition. So in order to now survive in this internet era, it was not just sufficient for you to know your basic operational reporting. Please understand, it was still critical for you to know the day-to-day reporting. How to run your organization on a day-to-day basis is still critical. But what I'm just mentioning is because now the competition or the market competition has become worldwide, if you cannot survive just with your operational reporting, you needed to know much more analytical and advanced capabilities about this reporting. So this particular ERP system is only able to provide you this day-to-day operation. So the question is, SAP said, I understand SAP ERP has its specific focus. It is helping me with operational reporting, but for me to compete in this new market, which is the globalization market, what additional softwares can I start bringing to complement my current operational reporting system, which is the ERP system? So in those terms, SAP said that one thing that is missing is a capability to do advanced reporting. I want to be able to go look at the data much more detail and start doing some forecasting, doing some predicting and all those things. So I can be better prepared to compete with my next door neighbors plus my neighbors from across the world. So they created 16 new products. I'm not going to list all the 16 products, but I'm just giving you an idea that 16 new products were created to complement the SAP ERP solution. The most critical ones are, the first one is called SAP BW, Business Warehouse. Business Warehouse is nothing but it is a data warehousing system. If I were to simplify it, it will take all the data, not only today's data, but let's say 5 years of worth of data from your SAP system, and you put it inside your business warehouse. So think of it as a large scale database. It takes all the data from your SAP ERP system and holds historical information. Now imagine if I have 5 years worth of information sitting in this business warehouse. Can I say, I'm going to take one particular example. I will say, I'm going to look at the last five summer season, and understand what was happening within the organization for that last 5 years summer. What kind of product was being sold? Maybe if I'm selling a car, if I'm a car manufacturing company, if you go look at what was happening in the last 5 years during the summer season, more and more convertible cars were selling in the market because the rooftop can go down. You can actually enjoy the summer. So now that I have historical information available within my business warehouse, can I now start predicting what's going to happen for this summer? It's a possibility, right? Now I'm open to that idea of starting to explore the data and say I can start predicting. Maybe when I get close to this summer, I stop reducing manufacturing the regular cars and start focusing on manufacturing more of convertibles, knowing that there is a market for convertibles during the summer season. Now I'm doing forecasting. I'm planning for what's going to happen in this summer. Does that make sense for everybody? This is the SAP strategy. This is how they started evolving, right? They understood their operational reporting supported by the ERP system is very critical. But to be able to be better prepared to work in the globalization market, they are adding a newer technology called as SAP Business Warehouse, which helps you tackle this one challenge that you have, which is analytical reporting. The cycle is complete. In those days, do you think that they would have called the customer every week to know how the product was doing and is there anything they could do to help serve the customer better? No, those days that was not the concept, right? A sale is nothing but you interact with your customer, you get the sale done, and then you move on to the other customer. That was okay in the 1970s and 1980s. But with the globalization era, with the market being so fierce and the competition being so fierce, if you did not have continuous interaction with your customer, so essentially basically talking about customer service, it became very difficult to retain a customer. A customer would jump from one organization to other if they come to know that there is better service being provided by another organization. So what happened when the logistics in the 1970s and 1980s was focused only on sales and distribution? The sales and distribution now got further divided into three main categories. One is selling was not so simple as just picking up a phone and calling a few customers within Michigan in this case, and calling them and saying, hey, you know what, I have a great product, I want to sell it to you. You have to, the sales cycle itself got broadly categorized into three subdivisions. One is called pre-sales, that is marketing. You have to first market your product. How can you become competitive and better than your competitors who are not just your neighbors but across the globe? Once you do pre-sales, which is marketing, you do the actual sales. So actual sales is very similar to what you used to do in the previous era. But once you have completed your sales, your job doesn't stop there. You have to do post sales, which is customer service. So SAP understood that just having a logistics team and doing sales and distribution and tracking that alone is not sufficient. You have to now start tracking pre-sales, sales, and post-sales. So in order to perform these three operations, SAP came up with one of the 16 new products was called SAP CRM, which is Customer Relationship Management. So customer relationship management, think of it as an advanced capability of your logistics, sales, and distribution. So sales and distribution is basic functionality. You're complementing it with additional capabilities called customer relationship management, which takes care of pre-sales and post-sales capability. All right. So similarly, if you take material management was focused on mainly how to convert raw material to finished product. It did not worry about how you are dealing with your vendors. How can I get competitive vendors? Because in those days, you were only focused on, if you knew a vendor, you probably stayed with that vendor forever. Even though the cost price was extremely exorbitant, because you had that relationship, you would have continued to work with that vendor for a long time. But in the competition, in the new globalization market, you are now open to vendors from across the world. So you could actually, your supplier or your vendor, you could effectively manage that. You can go to the best bidder, you can go to the best provider, and you can pick them and choose them to improve your profit gap. So old era, it was focused on just material management. The advanced capability of that was called as SAP SRM, Supplier Relationship Management. So just like this, so many other products for plant maintenance, there was an additional product called as complementing product called as APO was created, called Advanced Planning Optimizer. How do I efficiently manage my plant maintenance? So this is how several of the 16 products got created. I just highlighted a couple of them: Business Warehouse, BW, CRM, Customer Relationship Management, SRM, Supplier Relationship Management, APO, Advanced Planning Optimizer. Some of these advanced tools came into the market to complement and supplement the current operating reporting solution, which is your ERP system. Having looked at this, though we identified a challenge from the old era, we created several new products to support and complement it so that you could eliminate some of the challenges that were presented in the 1970s and 1980s. But with the new technologies evolving every day, SAP started feeling the pinch that there were some challenges even in the globalization era. So here, what happened is, one of the challenges that they saw was, they realized, okay, now I'm capable of supporting my ERP to an advanced level because I have a business warehouse system, I have a CRM system, I have an SRM system and an APO system. I'm well placed within the market. But even though the problem of analytical reporting was solved by creating a new product called business warehouse, it's okay to store all these 5 years of data in a powerful data warehouse. But at this point, SAP by itself did not have a set of reporting tools that can present this information in a better way. The type of tools that SAP was dependent on was like Excel based and things like that. Very rudimentary, or it had to go to another company's reporting tool. It had to rely on, so if an organization bought SAP products, for the reporting, they still needed to go out of SAP and go to a third-party reporting tool and get those reporting tools to run the reports. So the reporting or the visualization capability was lagging within SAP platform. So if you were to come out of this globalization era and figure out what was the one big challenge that SAP had, SAP did not have a reporting tool platform within the SAP portfolio. So that is how they evolved and started moving into this 2000s. In the 2000s, one of the challenge was SAP said, I think we are well placed to support both ERP and the advanced components that they had created. But one big challenge they had was they did not have a reporting platform within SAP. So at this point, SAP and IBM were out in the market. I'm talking in the 2005-2006 timeframe. They were out in the market trying to acquire their own reporting companies. So there were two big reporting products or companies that were in the market. One is called Business Objects, a very popular reporting tool. And there is also another called Cognos. These were two reporting platforms or companies that were widely being used across many organizations, no matter whether they used an SAP ERP solution or an Oracle ERP solution. At the end of the day, the reporting information was visualized either using a business objects reporting tool or a Cognos reporting tool. So SAP and IBM were in the market to acquire a reporting company. SAP went ahead and acquired business objects. IBM went and acquired Cognos. So in 2006, SAP acquired Business Object and it became called as SAP Business Object. So by acquiring SAP Business Objects, SAP was able to add a portfolio of reporting tools. To name a few, Web Intelligence, Designer, which is no longer used. There are many tools, Designer Studio, analysis for Office, for OLAP. There were several products that were available within the Business Objects list of reporting tools. All these reporting tools were acquired by SAP. So now all this information, whether it is operational reporting or whether it is analytical reporting, all those could be visualized using one of these tools. Now, so they were looking at challenges that were available in their current platform, and they started building additional components to complement it, right? Similarly, if you look at it, as we talked about the SAP ERP system, what was the architecture it was built on? Can anybody help me? Was it an R1, R2, or R3 architecture they finally landed with? Can anybody help me out? What was the final architecture on which SAP landed? It was R3, right? Perfect. So there is a client, there is an application. Here is where your SAP application resides, right? It could be an ERP application, It could be your business warehouse application, it could be your CRM application, it could be your SRM application, or your APO. Any software stays in this layer. And then you have your database layer. For a very long time, now you can see that SAP has now added many portfolio to the application layer. Would you everybody agree? They have brought so many different components, right? There is ERP system now, there is business warehouse, there is customer relationship management, supplier relationship management, all these. They have added a list of application to their existing portfolio. But when it came to the database layer in your 3-tier architecture, SAP had no presence when it came to a database. So no matter what, SAP could, when it goes to an organization, it could give you a list of applications. But when the organization had to support it with an underlying database, SAP did not have any database of its own. So they always had to be supported by a SQL Server or by an Oracle or by a Teradata system or an IBM DB2. Companies always had to go for a third-party database to support your SAP application. Looking at this, SAP understood that there is a potential for us to grow in the database market. Now, I don't have complete monopoly over this portfolio. I am only a leader at the application layer. So even though I am really superior in the application layer, imagine this, right? I'll give you an analogy just to put things in perspective. I might have a great Ferrari body for the car. The body of the car could be of a Ferrari, but the speed of the car is still going to be controlled by the engine that you have, right? What if you had a Toyota or a Honda engine inside a Ferrari body? It is still only going to perform as fast as the engine underneath that car. Would everybody agree? So similarly, in this analogy, if you look at it, even though my SAP application layer, which is corresponding to the Ferrari body, the sleek looking, the most elegant application, it is only as good as its underlying database. If the underlying database is slow and it is not powerful enough, your application layer can only perform so well as your underlying database. So they understood that SAP, even though the application portfolio is really big and really amazing, I am not able to perform at my full capacity until I am dependent on some third-party database. And if you look at all these third-party database, they are all traditional RDBMS system. What does that mean? RDBMS stands for Relational Database Management System. That's the traditional name of any system. So they looked at this as an opportunity and they said, what is a traditional RDBMS system? Just to give you a perspective of what we are talking, let's assume that you have a laptop or a desktop. You know that your laptop has, let's assume that your laptop has some configuration. Let's assume that it has a 1 terabyte hard disk. And let's assume that it has a 4 GB RAM. So what happens? Every time a user is trying to access some information from your hard disk is nothing but a disk, right? It's a mechanical device. So every time I'm going to ask for an information, the information gets passed to your hard disk. The hard disk typically, because it's a mechanical device, it is limited, right? If you remember, hard disk running speed is measured typically in like 3200 RPM and so on and so forth. RPM stands for rotation per minute. So in order to fetch information that you're asking from your computer, the information is passed down to your hard disk to search the information within your hard disk. Hard disk rotates at a certain rotation per minute. It has to rotate. The mechanical device has to rotate. And then after it finds out, it sends the information back to your screen. Is everybody comfortable with this information? So that's how a typical hard disk works, right? Because it is a mechanical device. Anytime you ask for some information, when you're searching for a file or when you're looking for something, when you ask for that information, it has to go look into your hard disk, which is a mechanical device. It has to rotate. It has to churn. It has to figure out where the data is, and then it brings back your information. Once you have brought back your information, if it is something that is very commonly searched by you, your computer also has something called as a main memory. What happens is, in your browser, you have something called as a cache, right? Most commonly searched things are cached in your browser. Similarly, if you're looking for a file very, very often, what happens is the computer also has something called as a main memory, which is a small section, but it's all memory. It's not a hard device. It's not a mechanical device. It's a memory, just like your flash drive, your pen drive, which contains your information. So to retrieve information from your flash drive or from your pen drive is much faster, if you all understand it. So anything that is cached is going to be staying in your main memory, and the next time you search for that, it will take it from the main memory and give it to you right away, rather than asking your hard disk to churn and figure out that information. So this is how a typical computer works. Now, SAP looked at this as an opportunity and said, all traditional databases like your SQL Server, your Oracle, your IBM DB2 runs their databases like a traditional hard disk. So think that SQL Server, Oracle, and IBM DB2 are running on mechanical devices. When you send data, let's say I have an SAP application, let's say SAP ERP, it is sending data to one of these traditional databases. To store the information, it has to churn and store the data. To retrieve the information that I'm asking from the ERP system, it has to churn the data and send it back. So can you see the analogy that there is definite limitation with SAP system application being supported by a traditional database? Can everybody give me a yes or no if you can understand the potential limitation that a traditional database had to support with your SAP application? So you can understand it, right? You are limited by that mechanical capability of your database. Correct. So when I say product, I'm talking about the software, the ERP, the application layer, the business warehouse, and so on and so forth. Okay. So SAP looked at this and said, I am being limited by my traditional database. If you look at it, there is this small area where it's called the main memory or your RAM. Whatever data was stored in my memory, I was able to retrieve it extremely fast. Why not have a database that is completely running on a main memory rather than a traditional disk-based database? Imagine if this entire 1 terabyte database, instead of sitting in a disk, if it was sitting, all of it was sitting in main memory. Imagine your entire organization's data was being cached in a memory. Then how quick would you be able to retrieve that information? Would it be much, much faster than your traditional databases, or would it be the same? What would you think? If the entire organization's data could now be possibly located in your main memory or in your memory, then the data retrieval becomes extremely faster. So the software can be now well supported by a main memory database. Much faster, right? So they identified the challenges that was available in the market, and they came up, one of the biggest accomplishments they had in the 2000 era was, after acquiring the reporting tools, they looked at the possibility or opportunity to come up with a database solution, and they came up with a product called as SAP HANA. HANA is a in-memory database. Now, can everybody understand and appreciate why a HANA system is called an in-memory database? There is no traditional mechanical device that is storing your SAP system, SAP data, the entire database. So what happened? They said, I no longer to support an SAP application, whether it is ERP, whether it is BW, whether it is CRM, whether it is SRM, so on and so forth. To support any of this application, I no longer needed the traditional database like the SQL Server or Oracle or whatever it is. They said, instead, we have created our own product called SAP HANA, which is storing everything in memory. So now any of these applications can start running using a HANA application, HANA database. So what is the benefit out of it? You are no longer dependent on third-party vendor company for database support. SAP now has its own platform for database, and that is how SAP HANA came into the market. Does that make sense for everybody? See, this is how SAP product evolved when you look at it from the 1970s to today's date. This is how the SAP market came into existence. Now, now that you have an understanding of where we started and where we are right now, this is how the platform has evolved. So in our next session, we will go into, Rafael has a question. Can you repeat? So if you look at the whole scenario, right, Rafael, if you looked at this particular evolution of the product, you will see that we started with an ERP solution and we understood the challenges, brought in new products to the market. Again, when you brought the new products, you understood what. So in the old era, it was the operational reporting, no analytical reporting. In the next modern, in the globalization era, you were able to bring advanced reporting, but you did not have a good visualization. You brought the good visualization. You found out there was no proper database to support it. We moved on to SAP HANA as a product. And then once SAP HANA was created, SAP HANA, now if you look at the roadmap, if I were to draw a line graph with time in it, right? Let's say 2010, 2012, 2014, 2016, 2018, 2020, going forward, SAP HANA as a database came into the market in 2010. Now, think about it and tell me, there could be several hundred or thousand organizations that were using SAP application. It could be an ERP application, BW application, CRM, so on and so forth. They could have been using this application being currently supported by a traditional database like Oracle or SQL Server. Do you think it would have been viable for SAP to go into the market and say, hey, you know what? I go to a company like GE or Pepsi or some big company which has been running their SAP applications with some traditional databases for a very long time. I go to them and say, hey, you know what? We have come up with a new database. It is extremely powerful. Why don't you go? I know that your company is running SAP ERP on a SQL Server database. Why don't you go ahead and scrap your SQL Server and replace it with HANA? Do you think if SAP had taken this approach, going bold out in the market and saying that now that I have a powerful database, go ahead and scrap whatever underlying database you had for your SAP application, replace it with HANA? Do you think any organization, any big organizations would have accepted that as a proposal? Nobody, right? Because nobody knows the track record for SAP HANA as a product, as a database. So what was the best way for SAP to penetrate the market with SAP HANA? What they did was, they said, they realized that companies which was running an SAP ERP or SAP BW or SAP CRM, in which system do you think the SAP BW or SAP CRM or SAP ERP? Let's take it this way. So if this is run by Oracle if this is run by SQL Server and this is run by IBM DB2, I cannot go ask them to replace all this with HANA. So what SAP did was, as a small prototype challenge, they went to organizations and said, I know your ERP system has finance, logistics, and human resource modules, right? And each one of these has several applications like accounts payable, accounts receivable, general ledger, and so on and so forth. Let's do one thing. Right next to your SAP system, that is your SAP ERP being supported by Oracle, I will stand a simple HANA system on the side. I will bring a SAP HANA system on the side. All I ask of you is, give me one critical application within your SAP team, SAP system, on which there is a lot of demand for reporting, but you're not able to satisfy that reporting because it's taking a lot of time because it's being supported by Oracle. Give me just one application from your module. We will take that data, put it into the SAP HANA system, and we will run reporting on top of it, and we'll show you the capability of what SAP HANA can do. So in this case, SAP HANA acted as a secondary database. What is the primary database still for the ERP system? It is still, let's assume that in this case, it's Oracle. I am using the HANA as a side system. Is everybody understanding the concept? So they stood a SAP HANA system on the side of your SAP system as a standalone SAP HANA database, passed one application's data to that database, and started reporting on top of it. So by doing that, they wanted to show the capability of HANA database, the in-memory database, how fast it can help you with reporting. And that is how SAP HANA penetrated the market. So the way they penetrated the market was by something called as sidecar approach. SAP HANA acting as a secondary database to help solve a particular problem. This is how SAP HANA got its foot into the market. Once companies started using it as a sidecar, a small system on the side to help show the improvements, performance improvement for reporting. Yes, the application is very powerful, right? Because it is now complemented with so many other applications, ERP, CRM, BW, and so on and so forth. The application is very powerful. It's very sleek and very powerful and very efficient. But if it doesn't have the similar power in its underlying database, it's going to be limited by that capability, right? That was the main problem. Now, by sending the application data, the ERP data into the app, let's say accounts payable data into HANA, and by showing that I can run the report much, much powerful. Imagine in the 1990s, it was okay for me to run a report, and the report will run overnight for like several hours. And by the morning time, when I wake up, when I go to the office, the report data will be ready. That was an acceptable option. In the current market, can I ask a user, a business user, to run a report and wait for 5 minutes to get the result? Nobody is going to accept that, right? If you look at the current technology, the state of art of technology, if I ask my users to run a report and wait for half an hour or 5 minutes or even a minute, it's too much to ask. Everybody wants the data instantaneously. So imagine, even though my SAP ERP system is capable of generating reports at a lightning speed, but it can only bring data from an underlying database that is traditional in nature, I'm limited. My report cannot run faster. But imagine if all my data was sitting inside an in-memory system, the time taken to generate the report is going to be lightning speed. So that is how SAP HANA came into the market. To show its worth, it started off using a sidecar approach. Once the sidecar approach became popular, SAP said, the organization started realizing the worth of SAP HANA, but they were still hesitant because there were not many organizations which had said, I'm now so comfortable with HANA, go ahead and replace ERP system is the crux of your organization, right? That's where every information about your organization is stored. You don't want to jump the gun and replace it with an HANA system. HANA, even though it has showed promises, companies were not ready to make that plunge and say, okay, I'm going to replace my database that is supporting the most primary critical application, which is ERP, and replace it with a HANA system. So what happened? Between 2010 and 2012, companies started saying that there is this BW system. BW system is more of an advanced reporting system. It's not the main ERP system, right? Whatever data is there in the ERP is taken into BW for more of advanced reporting. It's not the source of truth. That's not where your transactions are being stored. It's only an additional system that is helping you with advanced reporting. They said BW is less critical in nature when it compared to ERP. I am comfortable with the sidecar approach. Why don't we take HANA to the next level? Company said we will go into SAP BW and run it on HANA. So companies started looking at SAP BW, which is being run by another database, and they said we are comfortable, we will go ahead and start migrating all our BW systems which are running on a traditional database into HANA. That's how the market started. Slowly SAP BW running on HANA became popular. People became more comfortable. They said, now I will run SAP CRM on HANA, SAP APO on HANA, SAP SRM on HANA. And as and when more and more companies started running their not primary but supporting applications, SAP said, now it is time for us to make the plunge and say, we can also start running SAP ERP on HANA. So between 2012 and 2014, 2015, you would see that companies started moving their SAP applications to be running on SAP HANA. As SAP was doing more and more research and development on this HANA database, they realized the potential of SAP HANA. They said, we are running now. It used to be that SAP application was the Ferrari body and the database was a very old engine, right? Now what has happened is the table has turned. The database has now become the Ferrari, and I'm still running the SAP application. Now it's probably looking more like a Lexus or something like that. I now have the opportunity to upgrade my application layer. With the capacity I see with the underlying HANA database, now I have the potential to improve the application layer. And they said, I'm going to fundamentally rewrite the ERP application. ERP was created with traditional database supporting it. That was the mindset, right? When the applications were created in the 1970s till the 2000 era, if you look at it, it was primarily created with the fact that it was being supported by a traditional database. Invention of SAP HANA database, now they realize that the application layer can be even more made sophisticated to be working hand in hand with this great product called as SAP HANA. So they rewrote the SAP ERP application, and that became S4 HANA. This is an ERP created by SAP only to be able to run on SAP HANA. It is designed exclusively to run on HANA. So you cannot take a new S4 system, the new ERP system, and you cannot make it run on any traditional database. It will not work on anything else. It will only work on HANA database. So that is how. So you would see, if you have been following the roadmap, SAP came up with something called as simple finance. They first took the finance aspect of SAP ERP and they upgraded it to work on S4. They saw the potential, people started accepting it. Then they moved into S4 HANA. Since, let's say, 2015, SAP has been, S4 HANA has been creating new releases. And now we are at S4 HANA. So that's where S4 or the HANA portfolio is going toward. Does that make sense for everybody? By a quick show of yes or no. So this is how the product evolved within the SAP portfolio. How ERP as a concept evolved, and then how did SAP take the opportunity of solving this ERP problem, and how did they come up with a company? How did they start off with an ERP solution? How did they evolve? And then we looked at the three major time period, the 1970s to 1980s, and then the 1990s to 2000 and 2000 going forward. We saw how the product evolved, what were the capabilities, and then what were the challenges, how to solve those challenges, did they come up with new products, and then what were the new challenges they faced, and we saw how things evolved.
All right, let's test your knowledge. Here's a question for you. Which of the following is a key feature of SAP HANA 2.0? Option A, in-memory computing. Option B, columnar database. Option C, predictive analytics. Option D, all of the above. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck! Type the correct answer in the comment section. Hey there, ready to master SAP HANA 2.0? Our course is here for you. Learn at your own pace, all on our platform. In this course, you will dive into SAP HANA 2.0. Think of it as your go-to toolkit for managing supplies, ensuring we have what we need, where we need it. From the basics to advanced tips, we cover it all. Crafted by experts, you are in good hands. Your instructors, seasoned pros with heaps of experience. They are here to guide you and tackle any queries you might have. And guess what? Our students love it too. Just like you, they have found our course incredibly useful. And the best part? It's budget friendly. Learning doesn't have to cost a fortune. Ready to become a SAP HANA 2.0 whiz? Sign up today. For more details, head to ZaranTech's website.
We're going to be talking about Introduction to HANA. It's a continuation of what we discussed last time. If everybody remembers what we did, we talked about the evolution of SAP as a product and as a portfolio. Can anybody tell me, we talked about what was this ERP system, Enterprise Resource Planning, and we said in 1972, 5 ex-IBM employees combined together and started this company called SAP. What was the first product that SAP created? Can anybody on the chat window type in the answer for me? What was the first product called as? So the first product that was brought out by SAP company was, if you remember, SAP R1, right? R1 stands for, R stands for real-time integration, and 1 refers to one-tier architecture. And does anybody remember what was that one tier in which SAP was installed? We are talking about 1970s time frame. So what could have been that? Perfect. Thanks, Kofi. So the one main, it was built, it was installed on top of a mainframe system, and that's how the systems were created. Then we know that we went on to R2, 2 being the two-tier architecture, application and database, both sitting within one server. And then we went into R3 as a product. The 3-tier architecture here stands for a client, application server, and database server, all living independently of each other. So we looked at all this information, and then we went through the evolution. Hope everybody remembers. We went through 3 different periods. I'm not going to talk about each one of them individually. If I were to broadly categorize them, we started off with SAP ERP as the idea in the 1970s to 1980s. We understood what were the goal and what were the challenges. Day-to-day operational reporting was key. No advanced reporting. That was the issue. We moved on to the next generation, which is 1990s to early 2000. We called it as the globalization era, SAP came up with 16 different complementing solutions. One of the key product that came, if you were to identify one key product that came out in the 1990s to 2000, can anybody tell me what was the biggest challenge in the previous era? And in order to solve that, what was the key object that was created during the 1990s to 2000 time frame? SAP BW, right? Business Warehouse was created so that it could help and directly answer this question of advanced reporting. We understood what were the opportunities because it was now able to provide reporting, advanced reporting. But what was the challenges? I think Mike already answered the next question. Perfect. Thanks, Mike. The challenges that we faced is we did not have a good reporting tool. It's very critical that we not only have the capability, but we should be able to present that information in a nice manner, right? The rendition is also very important. So in the next generation, which is from the 2000 going forward, one of the key things that SAP did was they went and purchased a company called Business Objects to get a set of reporting tools. We looked at that, and we also saw that the subsequent invention or new products that were brought into the market, one of the key things is SAP HANA. And we looked at the reasoning as to why we maybe at the surface level, we touched upon why we brought SAP, why SAP company brought this new product called SAP HANA. We said that at that point, SAP did not have its own database. This was the reasoning I had provided to you in the last session, but that's not the entire truth. I was slowly bringing into the concept of why SAP HANA came into the product portfolio within SAP. But there is a little more information that needs to be provided to you to be completely understanding why SAP HANA came into the market. Is everybody good with the information so far? By a quick yes or no, please, so that we can move on to today's session. Perfect. Thank you. So that being said, today what we are going to focus on is we are going to try and answer a little more in depth the question of why. Why SAP HANA? We touched upon the surface and said that SAP did not have a database of its own. So it came up with a product called as SAP HANA. Did that happen overnight? Did they just go to sleep and the next day morning they came up with a product SAP HANA as a database? No. There is a little bit of background behind it. Let's try to answer that question of why and what today. If time permits, we will go into the next level of detail, which is the how question. Let's take the traditional SAP product. What is our traditional SAP product? We know that there is an SAP software. The software can be SAP ERP. Let's assume. The initial problem was that it was being supported by a traditional database, like let's say Oracle or SQL Server. This is how a traditional system looked like. So what was the intention of an ERP system? Let's take a simple example just for us to understand what's going on. If I go to a Walmart, or if I go to a Kroger, or if I go to any grocery store, what you do, you go and purchase an item, and you will see that there is a person sitting in front of a computer or a register, or it's called the point of sale system. You go and make the transaction with them. You say that I am buying 2 shirts and 1 trouser and so on and so forth. And they enter that information onto this point of sale computer. All we are doing is you are establishing a transaction. When you establish a transaction, when there is a transaction between the company Walmart and the customer, that information about what the customer is, it will essentially look something like this. Customer, let's say customer name is ABC. Product, it will say shirt. Quantity, 2. Price, let's say $20 or whatever it is, right? This is the kind of information that is being captured when there is a transaction happening between a customer and the company. So this information, this record about that transaction needs to be passed on to the database. There are small tables sitting here inside this database, and that information is getting stored inside this particular individual tables. So if you look at the transactional system, the name of this transactional system is also called OLTP. OLTP stands for Online Transaction Processing System. OLTP, Online Transactional Processing System. So what is the key intention of an OLTP system is, anytime a transaction is hitting the system, its primary job is to take that data and store it in respective tables. So the key function of an OLTP system is to store transaction, or in a little bit technological term, if I have to say, whatever transaction is getting brought over here, that needs to be written into a table. Is everybody with me so far? Is it making sense? The intention is, if I go and purchase something in Walmart and I make a transaction, the primary function of that particular system is to take that data and push it into a table within the underlying database. The underlying database could be supported by an Oracle system, or it could be by some kind of a database. The primary focus has always been on how to efficiently store the captured transaction in the underlying database. But as and when data got stored in this particular database, users, let's assume that I am a user sitting in the headquarters of Walmart, and I'm one of the business users. I'm interested in knowing what kind of sale happened today. How do I get to know that information? This user now will ask for a report. He or she will say, build a report for me, which will go look at one or many of these tables individually and fetch me the data. Now, if you all understand from our previous discussion, a traditional database, it is driven by mechanical device, as I explained it last time. So there is a physical limitation for how fast a mechanical device can process, right? Everybody hopefully understands that concept. So now I'm saying that there is X amount of power in this particular system. Out of this X amount, I want to spend most of it for efficiently storing the data, that is writing the information. If you were to prioritize this database's functionality, the first priority will be, every time some transaction comes into the system, I have to take that transaction and place it effectively inside in the underlying table. That is the primary goal of a OLTP system. Now, all of a sudden, because this information is available within this database, users are asking for report information, which means now they are asking the system to perform read ability. I want to not only write it on this side, I'm now asking the system to read the information and present it to me for reporting. So can you see that there is going to be a contention? I have limited power as the database. Now I'm torn between writing the transactions into the table, and at the same time, users are demanding that I want to read that information, extract that information from that table, and be able to present it for reporting cases. So when this happened, they found out that there is a lot of contention or resource constraint or bandwidth issue. Given I have so much amount of processing power, I'm torn between writing and reading. This is not a good practice. An OLTP is primary goal is to be able to write the data efficiently, so that, because I cannot lose track of any transaction that's happening in the organization. So in order to solve this problem, what SAP did was, they said, let's bring another database. Let this database be either an Oracle or a SQL Server again. Let's copy over all the data. So essentially, copy data from SAP ERP to the system. So all the tables data will come and reside in this particular system. Now what they did, they created another application on top of the system, and they called it SAP BW. So what happened? On a nightly basis, data from here moves and gets copied over into this particular system. Now, the intention of this particular system is, they said, let's cut out this user request. Let's move this read ability to this particular system. Now, users, the same users, can run the report. This report will now be connected to this database, the database that is being supported by this application called SAP BW. And you can go and run all the reports you want without causing any resource constraint on the OLTP system. So this system, this is an analytical system. So this BW system is coined as OLAP system. OLAP stands for Online and Analytical Processing System. Online Analytical Processing System. All right. So now they solve the problem of running reports moving from this particular system to this particular system. So the challenges, can anybody tell me in this particular approach, what is the biggest drawback or negative in this entire process that we just talked about? Can anyone tell me what is the biggest issue that I'm going to, exactly, Virendra is absolutely right. I am unnecessarily duplicating data. Can everybody see that? If there was, let's assume there was 1 terabyte of data here, I'm moving that 1 terabyte of data again into this particular system. See, speed, in a way, it is now becoming better, right, Lokesh? If you look at it, if a report was run on this OLTP system, where that OLTP system is trying to fight between storing the transaction and retrieving the transaction for your reporting, the speed is going to be slower. But now that the data has moved into this BW system, that BW system is not capturing transaction. It is only meant for reading the data for reporting functionality. So what's happening? The speed has improved. But in order to make this facility available for your users, you have compromised on duplicating the data. On a daily, on a nightly basis, I have to push whatever data came to my Oracle or to my OLTP system. I have to keep pushing it into the BW system. So the negative is I am duplicating the data. The advantage is now I have better reporting. Would everybody agree? So one problem solved. I'm able to provide better reporting without causing any resource contention on my OLTP system. But on the contrary, I am compromising on another system holding duplicate amount of data, which means that I have to constantly maintain it, right? Every night I have to start pushing data from the OLTP system onto my OLAP system. But this kept growing. The BW system became the go-to reporting system for everybody in the organization. So what happened? Naturally, as and when you keep pushing data into the system, what's going to happen to the volume of data that gets stored? Naturally, the volume of data that gets stored in the BW system is going to increase significantly, right? Today, you have 1 day's data. As years goes by, the BW system keeps track of all your historical data. So now you are having multi-year data worth of data sitting in this system. So the volume kept increasing. When the volume gets increased, let's say I had 1 million record initially, but now I have like billions of records. I have billions of records to be processed for reporting. What's going to happen to my reporting performance when I continue to hit this system? The reporting performance is going to take a hit. Would everybody agree? With the increase in the volume of data in the historical SAP BW system, the warehousing system, the performance of the system is going to come down. So some of the things that a traditional SAP BW world did was they said, okay, I will look at this particular table. If this particular table contains let's say 2015, 2016, 2017, 2018, and 2019. Let's assume that 5 years of data is still sitting in this particular table. And looks like the users, when they run a report on a daily basis, they're currently only looking at 2019 data. So they came up with some technologies within the database, like indexing, partitioning. To help, they tried to partition this table into, let's assume that 5 different tables. One table containing 2019 data, one table containing 2018 data, so on and so forth. So what happened? They tried to lessen the pain caused by the increase in volume. And they said that instead of one table, I have split it into 5 different tables now. Knowing that the user is commonly asking for 2019 data, I will push them to the 2019 table and they can retrieve the data relatively faster instead of going through all the 5 years worth of data. But you can only do so much of partitioning and indexing, right? To make one thing better, you're now adding a lot more maintenance in your system. So in order to solve this problem, SAP, what they did is they kept constantly looking at what kind of products can I come up in the market, or look at examples that is happening in the market and see how I can improve this performance. So this was not just an SAP problem, right? This was an across the industry, IT industry problem, that with the volume increasing, how do I not compromise my reporting for performance? So SAP, with the help of few PhD doctorate students, they went and looked at several products. And one of the things that came back very promising is, if you look at the Google engine, Google search engine, if you can all imagine, when you type a question in your google.com and you hit enter, you get millions and millions of records instantaneously. How is it able to bring back that information? There is some kind of an algorithm or an engine that's running behind, a proprietary algorithm that's running behind the Google search capability. So they started understanding what is happening in those scenes, and they created a new product called Trex engine. They came up with the SAP company came up with a product along with these PhD students. They came up with a product called as Trex engine. And that Trex engine was converted into a product called as BWA. Or let me change this color. And I will say they came up with a product called BWA. BWA stands for accelerator. Think of it as a power boost to your system. So this Trex engine is completely in memory. If everybody remembers the discussion we had last time, I explained how a computer works. The first time you query a computer, it goes into the underlying hard disk and tries to process the information. But after the information has been processed, it will come and put it on top of your RAM. And the next time when you ask for the same information, rather than going to the hard disk, it now goes to the RAM, which is your in-memory, and the retrieval of information is much quicker. Hope everybody remembers that. So using that same technology, this BWA is completely, imagine that it is sitting in RAM. They brought this BWA system and they established a connection between your BW's underlying database and this accelerator tool. Now what happened? In order to solve the problem of high volume causing a performance issue for reporting, they started sending data from here to this particular system. Because this is now all in memory, when a report is run, it now knows whether I should go to this system and pull the data, or should I go directly to the memory rather than going to the hard disk? Should I go to the memory and fetch the information? So naturally, what's going to happen when the report is going to the BW accelerator, it's going to start performing better. If you look at the analogy that I gave you exactly for the computer, that's exactly the same thing. Think of this particular as your hard disk and this becoming your RAM. Now the report has a choice to either go to your hard disk or to your RAM. Now what could be the limitation here? The advantage is now I have solved the problem of reporting performance, because no matter how much the volume increases, as long as it's staying in RAM or in memory, I'm able to reach that data much faster. So I'm not compromising on my reporting performance. But just like you guys, everybody mentioned a few minutes ago, I'm still duplicating data. Would everybody agree? I'm still duplicating data. I have now added more maintenance to the process. I'm not only sending data from the traditional OLTP system to the OLAP system on a daily basis. I am now sending one more set of duplication of data into my BWA system. Now, looking at this, if you look at it, do you think that this is a sustainable option? As the data keeps growing, if I continue to be churning and duplicating the data from one system to the other, it doesn't seem like maybe 10 years, 12 years, 15 years ago, the amount of data we are talking about could be probably in high gigabytes or maybe touching terabytes. They probably go to 1 terabyte, maybe 2 terabytes. That was the maximum amount of volume increase organizations were seeing, even big organizations. But if you look at the last maybe 10 years or so, the volume has significantly increased. It's now companies are talking constantly in terabytes, even going into exabytes and petabytes. That's the kind of exponential growth that we are seeing with data. So if you take that thought process into your mind, can you tell me if this process, sending the data from your OLTP system to OLAP system and OLAP system into your BWA, is going to be a sustainable option? No, right? Because too much of work is happening, and it's definitely not going to be keeping up. And I'm doing a lot of maintenance work in addition to that. So SAP said, I really like this concept. We came up with a very nice concept called as in-memory accelerator, supported by this Trex engine. But by keeping it as a sidekick to my SAP BW system, I'm not gaining much out of it. They started looking at this product individually and said, what if we make this itself as a database? What if we can avoid an intermediate database and rather go use the BWA itself as a database? And that is how SAP HANA. So SAP HANA product was born out of this BW accelerator concept. Does that make sense for everybody? By a quick show of yes or no, please. This is very critical to understand, because this now goes into details of why SAP HANA came into the market. If you look at it, now we are talking about, we understand the why. BWA was a big issue, and in order to solve that problem, so now I'm solving two problems with one product. I could have not sustained the continuous growth of volume by using a BWA, because I'm going to duplicate the data. I'm going to maintain three different systems: OLTP system, OLAP system, and my in-memory BWA system. It's not going to be a sustainable approach. So that is the reason why SAP came up with a newer product called as SAP HANA. But when SAP HANA came into the market, as you all can now understand, because it came from that BWA concept, it was a pure database in nature. All it did was, it took the concept of this BWA. What is the proprietary concept of this BWA? The Trex engine. It took that concept and it became a completely in-memory database. But for a database to be called database is just, so what was this in-memory system capable of, the BWA? It was good for supporting my reporting. Or if I were to call it technically, it was good for read capability. For a database to be functioning as a database, can it just be able to do read capability? Would that be sufficient for a database to be called database? Or should the database also have the capacity to write information into itself? Just like the concept of OLTP, if you remember, the functionality of the underlying database of an OLTP system was to efficiently capture the transactions that are coming in and appropriately place them in different tables within the system. So wouldn't you think that a database has two critical roles? One, it should be able to write the data into individual tables, and at the same time should be able to read the data from these tables to help you with reporting. So read and write capabilities are very critical. So if you look at it, SAP HANA just being an in-memory database does not make it an authentic traditional database and can be compared with other systems like SQL Server and Oracle. So SAP also understood that just having copied that Trex engine capability into SAP HANA does not make it a well-rounded database. So what SAP did was, in addition to borrowing the technology from the Trex engine, they added two other technologies. So essentially three different technologies were married together to make this product called as SAP HANA. So now we are talking about what are the technologies. The question of what technologies came together to help make this database, SAP HANA database, a well-rounded database. So let's understand what are the three components. We all understand the first component is your Trex engine. Trex engine brings that in-memory capability. How to efficiently read information from your system. Trex stands for text retrieval and extraction. T-R-E-X. Trex engine stands for text retrieval and extraction algorithm. And that algorithm is mainly focused on giving the read ability to your SAP HANA. Now let's take the comparison of a SQL Server or an Oracle. If you remember, that correct naming terminology for these databases are called RDBMS, Relational Database Management System. For a database to be able to be called RDBMS or a traditional database, it should have the write capability. Just the read capability alone is not efficient. How do I get a transaction and how do I push it into a table in a correct format? Now at this point, SAP HANA only has this Trex engine capability, right? So what is lagging is, in order to make this SAP HANA a true RDBMS, to be able to compete with other RDBMS in the world, what was lagging behind is the write capability. Now, in order to get the write capability, there are so many other databases that are available in the market. So SAP, instead of starting everything from scratch, what they could do is they could probably have gone to one of these companies, acquired them, and took the technology of an RDBMS and plugged it into this HANA database to make it wholesome. But what happens is, imagine, you know that you have a Ferrari and you know that it's going to run really, really fast because of its Trex engine capability. But just because you need a steering wheel to drive this car, you don't want to put a heavy steering wheel inside your car, because in order to keep your Ferrari fast and sleek, you want to keep the artifacts or the objects inside that car to be extremely sleek and lightweight. You don't want to overload it with heavy objects, then defeating the purpose of having that performance, right? So what SAP was cognizant about is, they said, I want to go and look for a company which has a database which is truly RDBMS in nature, but I don't want a heavyweight database. It's like they could have chosen to go to a SQL Server or an Oracle and probably struck a deal with them and said, I'm going to buy your company and I'm going to bring your SQL Server database or your Oracle database capability into this HANA, then what is going to happen? I'm going to slow down the capability of this in-memory system by overloading it with a heavy relational database management system. So that was not going to happen. So as they were looking at different products, they came up with a online company called P Start Time. A P Start Time is a extremely lightweight relational database that gives you that apt information of how to efficiently write information into the system. So this brings the right capability of the RDBMS. So they said, they looked at this particular system, they said it has all the right capabilities, but it doesn't come with a heavy burden. So they went and acquired this company called P Start Time, and this supports that right capability of the SAP HANA system. Now I have taken care of my read capability, I have taken care of my write capability. But can anybody think of, I said there are 3 different technologies that came into, they were brought in, blended together to make this final product called SAP HANA. Can anybody tell me what is missing? Just looking at this particular system, what potentially is missing that is going to be solved by a third piece of technology? Can anybody think about what happens? Let's see if there is an answer. So Fred is saying reporting. See, I can now answer reporting with this particular capability. Would you agree, Fred? Because I have the Trex engine part of SAP HANA, it helps me with reading, which is nothing but reporting. So it is capable of now reporting the information that is already stored in the SAP HANA system. Somebody is saying parallel processing. The Trex engine will provide that parallel processing capability. I will talk about it right away in a few minutes, Aditya, so you will understand what we are talking about. So Kofi is saying storing data. Storing data is now capable because of the P Start Time, Kofi. That gives you the ability to store the data, write the data into the database. So storing and reporting is perfect. Fred, I think, got the answer. Fred is saying backup. Now let's think about it logically, right? If you take your pen drive or your flash drive, which is in memory, which is a RAM kind of situation, what happens if it gets corrupted? Let's say a lightning struck when you were using your flash drive, or something happened. What happens to let's assume that the flash drive had 1 terabyte of data stored in it. What happens to that particular RAM object or the in-memory object? It gets fried, right? The data gets completely lost. So imagine now I have a very powerful system called SAP HANA. The entire data of the system, 2 terabytes or 10 terabytes of data, is all now sitting inside this in-memory tool. What if a natural disaster happens or a power outage happens or something goes wrong and my database is shut down? Everything is volatile. Anything that sits inside a memory is volatile in nature. So when I reboot the system, all the data inside the system is gone. Do you think that any organization would buy this product if I say that, okay, as long as your company is capable of keeping it running all the time, you're safe. If at the time when there is a power outage, your data is all completely wiped out. That's not an acceptable scenario, right? So the third piece of technology that is critical to this particular database is, how can I back up this information? Everything that is sitting in the memory needs to be backed up only for situations where there is a power outage or some kind of a disaster happens to the system. When I reboot the system, I should be able to bring back this backed up data back into my in-memory. So SAP had explored creating a database long time back. They had created a product which was not successful, which is a traditional database. When I say traditional database, they created a product called SAP Max database, MaxDB. This is a traditional database. Why I call that a traditional database is it is driven by a mechanical device. Data is stored in a mechanical device, just like your SQL Server and your Oracle. Unlike your SAP HANA, there is nothing concept as called as in-memory. It's a true database where information is stored. So what they did is, we already have a technology called MaxDB. Let's bring that MaxDB here with the sole purpose of backing up my data. Now what happens is, every time a transaction or an entry comes into this system, into my SAP HANA, the data is stored in the in-memory capability. So everything is now stored in the in-memory. But consistently, that data is copied over into MaxDB. Is copied over into MaxDB. Now immediately some of you will ask me, if you are going to copy over all the data that is sitting in your memory directly in your MaxDB, aren't you doing anything? You're simply doing the same thing that used to happen in the BW. You are duplicating your data from here to here. Did anybody think of that as a possible question? In the previous time also, I was duplicating data. Here also, even though I've come into an in-memory technology, I'm still copying the data over into this technology called MaxDB. To help you answer that question is, unlike the BW system, where the duplication of data was used, whether it was in OLTP system or in your OLAP system, the data here was used for some purpose, the data here was used for some purposes. So they were actively being used. Whether it was sitting in your BW, whether it was sitting in your BWA, both the data were being actively used by some reporting. But in this case, the only intention of this MaxDB is to remember that the system is volatile and I need a backup. This only gives you the backup capability. Nobody can read or run report on top of this third technology. So this third technology is not accessible for anybody. Every time a data gets written into an in-memory, it automatically gets a copy of it sent to this backup only for true backup capability. It cannot be leveraged for any reporting, or a user cannot decide to write a transaction directly into the MaxDB. For the outside world, MaxDB capability is completely cut off. They cannot understand, they cannot touch it, they cannot retrieve information from it. It is exclusively kept for the volatile nature of the in-memory system. If power outages happen, immediately when the system gets turned back on, the copy of data from the backup MaxDB goes back into the memory. That is all it can do. There is nothing else you can do with this backup capability. So now SAP HANA, by bringing in these three technologies together, they have answered the reporting performance capability using the Trex engine. They have answered the traditional write capability using P-start time. And knowing that it is a volatile system, brought in the backup capability to help solve that issue of volatility also. Does that make sense for everybody? So these are the three different technologies that come together and make SAP HANA as a powerful system. A quick show of yes or no, please let me know if you can understand the information. It's critical to know this because anybody who's a layman who's just heard about HANA can talk about high-level stuff, right? They can say, oh, I know SAP HANA is an in-memory system. But when you go out right after this and join a project, you are going as a HANA consultant. You are expected to know what are the underlying technologies that are helping me make this SAP HANA database a powerful system. Now, we understand that the P-star time is capable of doing all my write capabilities. How to efficiently push the data into a table, how to split the data and send it into multiple tables, and so on and so forth. We are understanding that. But if you look at this particular case, the Trex engine, this is still looking like a black box to me. Would everybody agree? I don't know what is going on inside this Trex engine, but I understand it is helping me with faster read and reporting performances. But as a HANA consultant, as I said, you need to know more about what's going on inside the hood so that you appreciate and you can command. You can, when you talk to somebody, when you talk to, let's say, for example, you go into a project and the project is at early stages. You will be meeting with a senior management. And when you talk about it, you can explain. They probably would not know what SAP HANA database is made of. So you can showcase, you can shine there by giving them some additional information on what is actually happening within the system. So now we are going from this, we understood what the technologies are. We will go into how each of these technologies is working. This Trex engine provides multiple capabilities. There are certain things that are happening within the Trex engine that's actually making your system even more powerful. If I were to broadly categorize them, the advantages or what is going on inside my Trex engine is there are three broader categories of information. One is there is a traditional shift from row versus column storage. And I will explain. If you don't understand what it is, don't worry. I will explain it to you from scratch. You will understand it. Then somebody mentioned about parallel processing. I believe Aditya mentioned about parallel processing. We are not just talking about parallel processing. We are talking about massive parallel processing happening within the Trex engine. In short, it's called MPP. And finally, something called as a push-down mechanism. These three broader categories of information is what is making your Trex engine so powerful. So we will go into each one of this and understand what these capabilities are. And then you will be able to appreciate and now say that, okay, I know in depth how this in-memory tool is working. What are the differences from a traditional database to this HANA database? All right. So let's take the first concept, row versus column storage. If you take a traditional database, let's say SQL Server or Oracle, whatever may be the case, we are saying that data, when the data comes into the database into an individual table, we have a high level information of how the data gets stored, right? Let's say I have a table which contains customer information. There is a customer table. This table contains customer ID, customer name, let's assume customer age, customer address, and customer phone number, so on and so forth. I'm just giving you an example. Let's give it a number 1, maybe Tom, 25, ABC, and then phone number is 1234. Let's assume this is how a data would look like if you were looking at a table. Wouldn't you agree that this is how some information will be stored? Each column contains an associated row. This is the data. So let's take a simple example. In the same database, let's assume that there is a sales table. There is, let's say, year, country, product, and let's say there is an amount. Just assume that there is a table in this traditional database where you have a table called sales table, and it contains basically this 4 information. Let's say 2021, country United States. Let's call product as A and amount is $100. There is another product in let's say United States, and then I have product B 200, and let's say let's assume that I have a table like this which contains year, country, product, and amount information. Now, to explain what a row versus column information is, you need to understand how data gets stored in a traditional data storage in a traditional database like SQL Server or Oracle happens. You need to understand how, when the data is pushed into your database, how does it go sit inside the database? In a traditional world, what happens is data is stored in tuples, and I'll explain what it means. Imagine there is a continuous memory. Has anybody, I'm sure many of you would have, when you go into your laptop or your computer, the system will ask you to do a functionality called disk defragmentation. I'm sure many of you are familiar. Can anybody give me a quick yes or no if you're familiar with this concept? So what happens is, over a period of time, when you keep storing information in your computer, the information gets stored in multiple different places, creating a lot of holes in the system. When you do a disk defragmentation, what it will do is, let's assume that it put a file A here. Imagine that this is your memory, okay? This is your entire memory in your computer. You stored a file, and the file A got stored here. And then you put another file later, and that file got stored, let's assume file B here and file C here. Now, there is a huge hole in your memory. This is how traditionally any computer is going to store your information. It is not going to store file B right next to file A and file C right next to file B. It's not going to do that. It will individually place it in some place within your memory. When you do the disk defragmentation, it will go check all these empty spaces. And then what it will do is, it will remove this empty space and align. It will bring your file B next to file A, bring your file C next to file B. So bringing together all the files and storing them one next to other, so that at the end of this disk defragmentation, what your memory would look like is, it will say file A, file B, file C, and then whatever free space is available, that is available to you. So basically, it's a cleanup act done by your system. Now, the reason I talk about that is, now let's take this concept. Imagine that your database has this memory, and you are now asking it to store the data from this sales table. I'm pushing this data into this underlying database. Let's assume how the system would go about saving it in the traditional database. So think of it as memory chunks. Okay, there are memory chunks that are available in the system, in your database. In a traditional database, it will start from row 1. It will take the value for year, so it will plug it in the first memory chunk. Then it will move on. It will take the next value US, move on to the next A, move on to this one, and 100. It has completed the first row. It will move on to the second row, 2021 US B 200, 2021 India C, and 50. Can everybody understand what I'm doing here? It is, think of this as contiguous memory or continuous memory. Memory chunks that are inside your database. In a traditional system database, it will take each value and place it in its own memory chunk as it goes through every record. Does it, by a quick show of yes or no, can you understand what we have done so far? In a traditional Oracle or SQL database, it takes your data from the table, and this is how the memory is storing it. Now, by storing it, so there is, Mike is saying no. So imagine that you have a big suitcase, Mike. I'm giving you 10 different objects to store inside that suitcase. So a traditional database, what it will do is, it will take the first object, place it in the first position within the suitcase. take the second object, place it right next to it. So it will take contiguous space. You will arrange it, objects, take one at a time as it is arranged outside. You take it and you place it within the suitcase, one after the other. That is exactly what a traditional database is doing. It will store information read from the table. When it is stored in the memory, this is how it will store it. It will go sequentially, read one record after the other, and place it inside your memory. Now I'm talking about behind the scenes, how the table stores its data in the memory. Okay. Mike has a question. What happens when data is deleted? We'll get to that in a minute, right, Mike? Let me first explain as to, so if a data gets deleted, there will be a void, just like your defragmentation. That particular section will become empty. It will not be reused until a cleanup happens. Okay, this is how a traditional database is going to store every record. So if there are 1 million records, it will continue to go. Imagine that there is this never-ending memory chunk, and it will keep pushing your data in this format. Now, this is called, if you see, how is it reading the data? It's going row by row. Would you everybody agree? This is called row storage. In a traditional database, the data from the table is read row by row, and it is put into memory chunks in a contiguous fashion. Now, you might ask me, okay, what is so big about this, or what is so fancy about knowing this way memory is allocated, right? I'll explain it to you so that you will understand it. Now, I am a user. I want to run a report on this table, and I have some questions. My first question is, tell me total amount generated by this company. I have a simple query. I want to know what was the total amount generated by this company. By quickly looking at this table, a layman would say, how much is the total amount I have generated so far? Can anybody give me a quick answer? Looking at this table, can you tell me what is the total amount the company has made? 100 plus 200 plus 50 makes it 350. For a layman, it's very quick for me just to look at it and say, this is amount is 350, right? But let's look at how a traditional database calculates this. It will first, in your memory chunk, it will go through the first value, 2021. It will say, does it make sense for me to know what 2021 stands for? No. It will move on to the next field. US, is it a value that I need to be considering? No. It will move on to the field called product. It will now say, okay, does it matter what the product is? For the question that is asked, I want to know the total amount generated by the company. The year, the country, the product did not matter to me. But what is happening? Because the data is stored in a row format, the system will anyway process that information. Even though there is no value add to looking at 2021 or US or A as a value, it will still process that. And then it will go to this amount field called as 100. It will say, I think this looks like a information that I need to contain. So it will retain that information called 100. It will move on to the next row, 2021, it doesn't matter. US doesn't matter, B doesn't matter. It will come to the value called 200. It will say, okay, now I need to capture that information also. And then it will continue to do the same thing until it goes to the last one. Then it will calculate the value as 350. Is it helping understand why I'm going through this exercise? To show you how inefficient it is to store the data in the way that is presented now. If I wanted to get a summarized information, I'm interested in knowing what was the total amount generated by the company. All I needed to know was the amount information. But because I have stored the information in a row format, it had to go through every value and capture that information, no matter whether it has relevance or not, to find this answer called as 350. Let's assume that this probably took me 5 seconds to process the information. Next question, let's assume that I want to know which product. Let's keep it simple, right? So now that I've expressed a question, and to answer that question, I had to go through all the three records to figure out what the answer was. It took me some time. This is how the data is stored in a traditional SQL Server or Oracle database. Now let's take the same example and understand how data is stored in a HANA database. Why HANA database is different. If you take the same information, what it will do is the memory, again memory chunk, but you will see that the memory is stored in a different way. Instead of going row by row and figuring out the information, when a HANA is presented with data in a table, how it will store the information is it will go column by column. It will go look at the first column called year, and if the year value is repeating multiple times, 2021 is repeating multiple times, and there is 2020 repeating multiple times, and so on and so forth, it won't store all the values, all the repetition. It will look at your column and it will identify the unique entries that are available in this column called year. It will say, in this particular table, there is only 2021, and it will store one time 2021. Then it will go to the next field called country, and it will figure out US repeats twice, and there is value for India. It will go to the next value called product, A, B, C, because there is nothing common about them. So they're all individual values. And then it will store the data as 100, 250. Now, when you look at it from this memory chunk, you will say that I don't understand how the data is going to be, how this value is connected to this and how is this connected. That is the TREX algorithm that they won't reveal to us, right? Just like Google will not reveal what is the algorithm they have to have that interlink between the values, that they won't say. But imagine this is how the data is stored in your SAP HANA system. Try answering the same question with this. In this case, the system is, because it is storing data in a column fashion, what it will know? It will know that column year, column country, and column product are not necessary for me to calculate. It will directly read the column called as amount. The answer is 350. Because the data is stored now like this, it will have data is stored. There is a year, there is a country, there is a product, and there is a amount. Here it will store only one value for year because there is no repetition, there is no new unique values. Here US repeats twice, and there is India. There is product A, product B, and product C, 100, 250. This is how the memory would be storing in a column format. To answer your question about how much was the total amount generated, it will directly hit this column and say the answer is 350. This will probably take a second to fetch the information. So at a high level, can you see the difference in storing the data in a row format versus a column format? By a quick show of yes or no, can you let me know? Are you seeing the differences? A traditional row format, you have to process the information, even the unnecessary information, to get to the answer. But in a column format, you can directly hit a specific column and get your information. So just to elaborate on this a little more, when the question or the query that you have is summarized in nature, when I say the data, the type of the query that you're asking is asking for a summary type of question. Let me go back to the table here. If I say, if I had this particular table, let me repeat this table here so that I can explain the concept. So you have year, country, product, and amount. 2021, country US A 100, 2021 US B, year, product, year, country, product, and amount. 2021 US A100, 2021 US B200. Let's say there is 2020 India C50. I'm just giving you a variation of what we have. Let's assume that this is the table we have in the system. When I'm asking what is the total amount generated, it is summary in nature. Would everybody agree? I'm not interested in knowing individual records value. I'm just interested in knowing a summarized information.
All right, let's test your knowledge. Here's a question for you. What type of database does SAP HANA 2.0 use? Option A, relational database. Option B, NoSQL database. Option C, object-oriented database. Option D, hybrid database. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section.
Let's assume that there was another field called quantity, 20, 30, and 40. So tell me what was the total quantity ordered. Would everybody agree this is also a summary question? Perfect, right? So the answer is 90, but what we are asking for is, this again is a summary nature. In order to know that the value is 90, is there any relevance in knowing which year it came from, or which country it came from, or which product gave me that value? No, right? I'm not interested in any of those details. I'm just looking at overall high number. Tell me what is the total quantity generated. Whenever your question is summarized in nature, you will see that storing the data in a column format helps me retrieve the information much faster. Again, if I were to ask you a question, which country generated the most amount? Is that a summary question? I only need to look at 2 columns out of these 4 columns, 5 columns, right? In order to answer this question, which country generated the most revenue? In order to answer this question, I need to know the column called country. It is in a way still summarized, Vijayata, and I'm quickly explaining that, right? Because if you look at it, I did not want to know which year it belonged to or which product it belonged to, or I'm not interested in knowing the quantity. All I'm interested in knowing is, of this detailed table, if I go to these 2 columns alone, I can answer your question, right? So it is still summarized in nature. I don't need all the details of the table to answer my question. That's where I'm heading to, right? So as long as the questions are summarized in nature, and if you look at your analytical reporting, right, invariably your analytical reporting is going to always start with summarized question. Tell me what was the sales for this quarter. Tell me what was the sales for this summer. You always start at a very, very high level information. And if you want further details, that is when you will go from a high level information to the details, right? That's how analytical reports always work. So imagine now, for me to run the report, would you choose to store it in a row format traditional database, or would you choose to store it in a column storage to retrieve faster detail when the question is summarized in nature? The choice seems very obvious, right? If I go to a HANA database which stores the data traditionally in a column format, data retrieval is much faster in the column format. But you might even ask me the same if I were to probe this question a little more. But there are cases where people will ask me detailed question. Now I want to know, tell me everything about the transaction that happened in India. Now I want to know everything about the transaction that happened in India. Exactly. Vijayata is absolutely right. So when your question is summarized in nature, columnar storage beats row storage any day. It's extremely powerful when it is, because you can understand, right? Because it can directly go to the necessary columns only and fetch the information rather than processing every unnecessary record that is stored in the system. It can directly go to necessary columns and fetch the data. But now, on the contrary, if I had a detailed question, I need to know everything about the purchase transaction that happened for country US. I need the information about the year. I need the information about the country. I need the information about the product. I need the information about my amount and my quantity. I need value from every column. If I'm going to read the entire row, storing it in a row format might be better suited. The reason is, it goes to this table in a row format. It will check if the country is India. No, right? It will skip this record. It's not going to process this information unnecessarily. Is the country India? No, it won't process this. Is the country India? Yes. So it will go row by value, and it will fetch this information. In this case, let's say it brings back the data in 3 seconds. I'm just giving you a hypothetical number, right? Just for you to put things in perspective. If the same question were to be answered by your column storage, there is no direct advantage of exploring the column format, because in this case, you have to anyway read all the individual columns. You have to go to this year column and fetch the corresponding value 2020. You have to go to the country and fetch the value for India. You have to go to product, fetch C, fetch 50 and 40. Because now everything is individually columnized, maybe it will come back in 4 seconds. So when the question is detailed in nature, even though you can get the answer from column format, in this particular case, row format might have a slight advantage over column format. But just because you want to get detailed question, you cannot go to a traditional database, right? So you can say, anytime you want to fetch reporting data, whether it is summarized in nature or it is detailed in nature, you can blindly go to your column format, which is your HANA system. For detail, there might be a performance difference of 1 microsecond or maybe 2 microsecond, which for a layman, you will not see the difference. But there is a slight delay in the column format if you are going to fetch the detailed data. But the benefit you get when you retrieve summarized information is exponentially higher. What would take probably 10 seconds in a row format would bring that data in like 1 second. Yes. So the real-time example itself is the summarized information, right? Anytime a query is run, always 99.99% of the time, the query is retrieved at a summary level. The initial retrieval of information from a database is always a summarized information. So the time taken for the initial response of any reporting is going to be supported by your column format, anything that is run within HANA system. So it is extremely powerful. So you might, in your HANA database, when you create a table, and I will show it to you in the next sessions, when you create a table, the system will ask you for a question. It will ask you, do you want to create your table as a row format table, or you want to create it as a column format table? It will ask you for this choice. Now you might ask me, how do I differentiate? When will I choose a row format table for in HANA or a column format? If I chose a row format, I'm making my HANA table look like any other traditional database table. By default, if you do not do anything, it will always make your table as a column format table. If you look at the HANA database, typically system administration table, where every record has some configuration details, that is what will be typically a row format table. When in doubt, always create your table. Let the system create your table as a column format. Even if you're going to be reading detailed information from that table, you will not see any significant difference from a row format to a column format. Column format by default is superior in nature when compared to your row format. This is the direct visible change that we see going from a row format to a column format. Is everybody following me so far? By a quick show of yes or no. We can see that just by going into a column format, I am seeing a significant benefit in faster response time. It will, but again, it is not visible to a layman eye. It is so insignificant that you're essentially joining a summarized information on the column table to a detailed table, right? So it won't be humongous difference. You won't see it as significant when you're working on it. Define default. Oh, absolutely, Mike. So what I'm saying is, when you go into the system in the coming sessions, when we go look at the system and create tables, when you say I want to create a new table in the system in HANA, it will ask you for a choice. There will be a drop-down button which will say, do you want to create this table as a row format table or a column format table? If you forgot to choose this option, it will by default always choose column table for you, because HANA is built to handle column storage capability. So by default, it will always go and choose the column format, knowing that even if that table was to be bombarded with detailed question, a column format table can still handle that. Though there might be a very, very, very small difference in the processing speed, it won't be as significant as you would imagine. Like if you had asked that row, if that table was stored as row format and you asked a detailed question, it won't come back in 1 second. And the same question was asked to a table which is now column format, it wouldn't come back in 50 seconds. You won't see that kind of difference using a column format. If that was 2 seconds, this probably would have been like 2.5 seconds, something like that. Always choose, when creating a table, just choose blindly to create it as a column storage table. All right. There are a couple of other questions. Fred has a question. Will there be any need to store in the row format at all? If you know for a fact, there is a table which you will always only ask it for detailed question. There is no way you can summarize information. Let's say, for example, I have a student table. I have a student name, a student ID, student age. Let's say student ID, student phone number, and address. Let's assume that I have a table which has, there is no amount or measure, no measure is available in this table. Okay, hope you are able to understand the process, Fred. I have a table which only contains master data information, which means that there is nothing to calculate out of this table. I have student name A, student B, student C, ID number is 101, 201, 301, 123, 456, 789, and I have address. In this particular table, tell me, Fred, is there any need for me to do summarization? If I summarize the information in this table, there is nothing for me to calculate, right? Exactly. No data that needs to be calculated. So I always know for a fact that this particular table, if I'm going to use it for any reporting, I am going to be needing detailed information. I'm always going to be needing detailed information. So if you were to choose, if you were asked by somebody to say that you have to create some tables as row format, otherwise I'm not going to let you go, then you would choose such tables where there is no possibility for summarization and make them as row table. But even in this case, what I would say is, if you're not sure whether it should be a row table or column table, by creating this as a column table will not degrade your performance. Though this table was not built for capturing column level information, summarized information, if you had created it by accident as column table, nothing will go wrong. Does that make sense, Fred? Hope it answered your question. So this could be a master type of data where there is no calculation needed, is a good example for where you can use row storage. All right, there's a question from Felix. Do you have situation where you would extract data from multiple tables? Absolutely. Yeah, when we go into data provisioning concepts, Felix, we will explain as to join information from multiple tables, right? You will have to bring information from different tables. Absolutely. Mike has a question. Where would I choose row format? Yeah, when I go into the HANA system, Mike, in the subsequent sessions, I will show you how to create a table. And when I create a table, I will show you how to uh, choose that option. I will explain it step by step. And the even more cool feature in HANA is, let's assume that you went ahead and created a table. Let's assume the student table, you created it as column table, not knowing that there is an option for you to create it as column or store. You chose the default route and you went ahead and created a column table. You have loaded millions and millions of records into this table. And then you realize that, oh, this seems like a table which doesn't have any calculatable fields. I made a mistake of creating it as a column. I would really love it was if it was a row table. Even after having loaded the table into this column storage table, there are capabilities to convert this table from row to column and vice versa anytime. I will also show you how to, if you think that you have made a mistake and you want to switch it over, you can absolutely do it. And I will also, when I create the table, I will show you how you would convert a table from a row column to a column table, or to a column from column to row, vice versa. This shouldn't be an issue. Again, if you were to adjust the table structure to add or delete columns, it would still function the same way. There won't be any negative performance issue when you're doing it, because the internal algorithm, which is proprietary and that has not been shared, will be able to handle that adjustment of table structure. Vijayata has a question. Can we switch column table to row table? Perfect. I think I just answered that, Vijayata. There's a question from John. From what you're saying, it looks like column table is ideal for retrieving data. Do you also determine whether to use row or column for pushing data to? So the system internally, once you have defined a table, John, once you have defined it to be a column table or a row table, how HANA processes the data inside the table is going to be determined by the choice you make. If you chose the table to be created as a column table, it will behave in its default function. It knows, it's like fish swimming in water, right? It knows exactly how to process that data, sending into the column table. If you send the data into the table defined as row table, the Trex engine will not activate. If you remember, there is that second technology, the P star time technology. If you remember that discussion we had, that brings that right capability of a traditional database. So that will activate and say, I'm going to take over and send this data into a row table format. Does that make sense, John? That's how the system is going to differentiate. Okay, so that's why you don't want to confuse the system by making Trex get activated sometimes and P star time get activated sometimes. If you by default set it up as a column table, the maximum efficiency is brought by the Trex engine capability. Kofi has a question. With the speed capabilities of HANA, considering P star time, why emphasis on column over row? Is because the retrieval, right? It becomes critical when I'm running a report. Maybe 10 years ago, Kofi, it was okay for a report to run over the night and make the report ready for the user next day morning. It was okay for the user to wait for hours together to run a report. Now, if you go to any organization and you tell the report user to run a report, and if it takes more than, let's say, a couple of seconds, they are not going to be happy about it. They want data instantaneously. Now, the data retrieval, if it has to be instantaneous, what would you choose, Kofi? Given the choice of a row format and a column format, which would you use to retrieve the data? In this case, it makes sense to go for the column approach, correct? Because I have to retrieve the information faster. That's why I will choose always the column storage. All right. Sure, Virender, I understand. No worries. I'll see you in the next session. John has a follow-up question. Would you have to adjust the schema or index at any point in time? Perfect. I think you beautifully gave me the segue to the next topic that I need to discuss. I'm going to be talking about indexing and partitioning concepts right now. Mike has a question. This is for data retrieval. Yes. So to retrieve the data from the table, in the HANA table, if the data was stored in a column format, the retrieval becomes exponentially faster than compared to your traditional row storage format. But explaining the concept of row storage and column storage does not just stop at data reading or retrieval, right? Would everybody agree? So now we understand that by explaining the concept, we just understood column storage gives me the data reading capability. The data retrieval capability is significantly superior by going into a column storage capability. Would everybody agree at this point? We have understood that by keeping the data in a column storage, which is not usual in a traditional database, which is only possible in this HANA database, I am making data reading extremely faster, which means that I'm making my reporting much faster. But there are some underlying hidden advantage by going into this column storage. Let's take that same table. Bear with me, I have to write it again. I'll quickly write it. Country, product, and amount, just to explain the concept, subsequent concepts. I'll say 2021, US, product A, B, 100, 200. Let's assume that I have this data. In addition to this data reading, there are other things that happens in a row system versus a column system. In a traditional database, what happens is, in a traditional row storage system like SQL Server or Oracle, what's going to happen is, this table can contain millions and millions of records. Would everybody agree? This can be ever-growing table. A traditional row storage, if I send a query to this, if I ask a question to this particular table, by now you understand that if the data is stored in a row storage format, let's assume that there are millions of records in this particular table. And the question I'm asking is having the answer stored in, let's say, 999,998 record. Just short of my million records. Here is where my data is stored. The answer for my question is stored in this almost very last record of this table. A row format, to fetch this information, what is it going to do? It will continue to read the entire record by record by record by record all the way until it goes to the almost a millionth record. Saying itself is too difficult for me to say that number. So I'm going to just say almost 1 million record, right? Can you see that the time taken to fetch that information from your table, it has to scan your full table. The concept of a traditional row storage table to retrieve a result for a query goes through a full table scan. Imagine if it took 10 seconds for this traditional database to fetch this almost 1 millionth record. Imagine if this table was 10 billion records and your result were somewhere stored in the 900 million section. How much time is it going to take? It probably is going to take multiple hours to fetch through this, because always a traditional database will go through a full table scan. It will go record by record because that's how the memory is stored. That's how the information is stored in the memory. So it will go record by record all the way through until it finds the answer. It will have to scan the entire table. Tell me, is this a sustainable process even for a traditional row-based database, RDBMS system? If I allow the system to always do a full table scan, it's not going to happen, right? So what we do in the database world is, I'll give you an analogy. I ask you to find a word called XYZ from your book. You have a book in your hand and you have to figure out, I ask you information about a particular thing in your book. You can do one thing. You can start from the first page, scan through the entire page, go on to the second page until, let's say, if it's a 300-page book, the information is in the 250th page. You would have scanned through 249 pages until you get to the answer, which is on the 250th page. Is that approach correct? Or would you look at the table of contents and identify where this information would be and jump directly to that section and find out the answer? Which approach would you take? Is the choice of table of contents and jumping to the section better performance, or scanning the entire book is better performance? The analogy of scanning the entire book is like your full table scan, and using a table of contents and identifying where you have to find this information and jumping directly there is a better performance, right? So taking that same analogy, database has this concept. In order to accommodate ever-growing needs of a table will always be supported with a concept called as indexing or index. So what will happen is, for a table, you will, as a developer, will have to go and create another object called as index. What this index will do is, it will have a pointer. Let's say in this particular table, I am going to have pointers on my year and my country field. Then what I'm saying is, I will say year, I have index 1, which is going to be based on the column year. It will say 2021 value, and it will have a pointer field. It will say it's available in row 1, 2, 3, 200, 500, 700, 900, and so on and so forth. It will keep a track of 2020, and 2020 will say it's in column row 4, 7, 9, 11, 15, 21, 2000, and so on and so forth. Now imagine that it is just like your table of contents. A report needs to be run, and the report is asking, I want information about year 2020. I want all information about 2020. If I took the traditional approach of full table scan, it has to go through the entire 1 million record, identify wherever 2020 data is entered, and it has to fetch that information. Rather, if you had an index maintained on top of this table, it will go here, it will say, okay, now it knows these are the list of records where 2020 is available. So using this, it will go to this table and fetch only that particular table. So the indexing on top of this table is helping me reduce my table scan timeline. Indexing, just like your table of contents, is going to help me process the information a little more faster. In a traditional database like SQL Server or Oracle, indexing is not going to happen magically. It's not an automatic event that happens. You as the developer have to create it, and you have to go and maintain it every day. Today, the 4th record and 7th record had 2020, and somebody went and inserted a new record in the 5th position for 2020. I have to go update my index pointer. Right now, I have to say 5 is also containing the 2020 record. There is a lot of maintenance that needs to happen. Is everybody understanding what we are heading? In a traditional row storage system like SQL Server and Oracle, you have to do this additional indexing work on top of maintaining your table. On the contrary, because column storage in HANA treats individual columns as objects of itself. I have country, I have product. This is how the information is stored in the column storage, right? Every column is individual on its own. I have 2021, I have 2020. I have country US, I have country India. I have product A, product B, product C, 100, 200, and 50. Every column automatically behaves as an index by itself. You don't need to do anything special. So what you would have traditionally done in a SQL Server or Oracle is you would have had to do the manual step of creating an index and maintaining it. But in a HANA system where the system itself is maintaining the data as column by column, each column behaves as an index on its own. You don't need to create any indexes separately. Does that make sense? So that again is an unknown hidden advantage that you're getting, right? In addition to doing the data reading, now there is no need for index. You're not spending additional time maintaining and creating an index on top of a HANA column table. Just like that, in a traditional system, again, if the data volume goes significantly larger, you will partition the table. You will say that I'm going to store all my 2021 data in one table and then 2020 data in another table and so on and so forth. So in order to separate the data into multiple tables, you have to go through a partitioning concept, which is again a maintenance activity. You have to go as a developer, identify on what column am I going to partition the table and how many partitions do I need. And you have to constantly keep maintaining it. Again, in your SAP HANA, because your data is separated by individual columns, they are automatically partitioned. The system automatically, when it hits a 2 billion record, when a table in HANA, which is columnar in nature, hits a threshold of 2 billion records, until then it doesn't need to do any kind of partitioning because the table volume itself, the individual columns itself are indexed and partitioned automatically. You don't have to do anything. But the system also has an overwriting threshold, which says for no matter if your table crosses the threshold of 2 billion records, it will individually automatically go and create a partition and maintain it on your behalf. You don't have to do anything for maintaining that. So the advantages you're getting just by moving into a column storage is no indexing, no partitioning, and of course your main concern is extreme high reporting performance. Now, the final hidden advantage you get by going into this column table is, so I'll just quickly recap here, advantages of column storage. Read performance, no indexing, no partitioning. There are a couple of questions. Let me quickly read them. John has a question. Does it mean the column table already has a built-in? Yes, it has a, because it treats each column. If I were to put it in a very simpler terms, right, John? Think of a column table, takes each column in your HANA table as individual tables. It will treat each column as an individual table, and it has inbuilt indexing capability on each of those columns. So we don't have to do anything about indexing or partitioning with a table which is created in HANA. Mike has a question. Why would you need to partition a column? You don't need to. So the concept of partitioning will not be pertinent to a column. What it is thinking is, even when the data is stored, let's say, for example, each column in a table will have a lot of repetition value. Would you agree, Mike? In the case of the column called year, 2021 can repeat in several million records, 2020 can repeat several. But how the data is stored inside the table, it only stores the unique values within that column. Would you agree? So as you asked, it's a valid question. In this case, that column is not going to potentially have large volumes of information. If I'm going to store 5 years worth of data in this table, I will have 5 entries in this field, in this column called as year. But the reason why at a 2 billion record threshold, it automatically goes and creates a partition is, there could be some columns in your table. I can have an ID column or an invoice ID column. You will see that invariably all the values are unique. An invoice ID number will not repeat in every record, right? That possibly can have 2 billion individual entries, unique entries sitting inside that particular column. So what happens is, if you let a columnar table with an individual column having too many unique entries, you are starting to hit the degradation capability of the underlying proprietary algorithm. So they don't want to compromise the performance of the internal algorithm. So what they will do is, if assuming that you have a column in your table that can potentially have so many unique entries that can try to degrade the performance, they, out of abundance of caution, they will go ahead and create a partition on the table automatically. That's all it does. Hope it explains the question, Mike. That is where the concept of partitioning would come into play for a HANA column table. Is the 2 billion fixed? Yes. You can, on top of it, you can be, you can say that I don't agree with HANA's concept. I want to do it at 1 billion itself. You can override that. The default nature is 2 billion. If you did nothing about a table, which is what you would normally do, automatically when it hits the 2 billion threshold, it will go ahead and partition the data. So now we have seen that these 3 advantages are there. I will explain. There is one more unknown hidden advantage for storing your data in a HANA system with column storage than a traditional row storage database. If I have, let's say, 10 million records in a table, and it's a large table, let's say there is column 1, column 2, column 3, and assume there is like 10 columns in this table, and I have a 10 million records stored in this particular table. When this data is stored in a row storage traditional database, can anybody guess and tell me how much space am I going to occupy in my, if I were to, so this is my SQL Server database, let's assume. This is my SQL Server database. I have this 10 million record table with 10 columns. I have to store this data. Would it be fair to say that it could be like a 50 GB table, if I were to throw a number? Because I am storing every row's data in contiguous memory, so I can potentially occupy, let's say, 50 gigabytes of information. If the same table was stored in a HANA column storage table, where the system, how it does, it will take each column separately and it will only store unique entries into these columns. 2021 repeats 5 million times and 2020 repeats 5 million times in this table. The value of 2020 and 2021 will be stored in your database 10 million times. But in your HANA storage, it would be stored 2 times. Can anybody think of what's happening by going from row storage to column storage for a space perspective, from a space perspective? Would you agree that HANA will tend to store less amount of data for the same table? Exactly, right? So storage is compressed. Would everybody agree? If it took 50 GB to store this data in a traditional database, the same data, when it is stored in a columnar table, it will probably end up being like a 2 GB, because it is removing any redundant information from the table storage. Does that make sense? So that is another compression plays another significant advantage when you store your data in the HANA column storage format. So the capability of read performance, the capability of not needing to have an index, the capability of not needing to maintain a partition, and the advantage of inherent compression. These are all the advantages that is brought over by a Trex engine. So Trex engines row versus column difference. If I'm just talking, if you remember when I started this discussion about Trex engine, if I could go back a little bit quickly, let me just quickly go back here. If you remember, I said when talking about Trex engine, there are three major things that we need to talk about. Just talking about row storage versus column storage, we found that the read performance is improved, no index, no partition, and added compression. Is everybody clear so far? Critical for you to know this information because now you are now knowing the details behind what is happening with the Trex engine. In tomorrow's session, we will talk about what is this massive parallel processing, what is this push down mechanism. And then by knowing these things, you know exactly how in-memory computing is superior to its traditional counterparts. Please try to recap all this information before our tomorrow session so that you will have a better understanding when we go into the next topic of massive parallel processing and what is push down mechanism. By knowing these three concepts, what row versus column storage means, what kind of advantage it's bringing, what massive parallel processing is bringing to HANA's plate, and what push down mechanism is doing. If you understand these three concepts, then you know how that technology is working. Now you understand what are the three technologies that comes together to make your SAP HANA system, your Trex engine, your T-star time, and your MaxDB. Now we are getting into this question of how. By knowing these three concepts of row storage versus column storage, massive parallel processing, and push down mechanism, you will have a complete good understanding of why SAP HANA database in memory is powerful than your other capabilities or other traditional databases.
All right, let's test your knowledge. Here's a question for you. Which of the following is a benefit of using SAP HANA 2.0? Option A, faster data processing. Option B, improved data security. Option C, easier data integration. Option D, all of the above. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there, ready to master SAP HANA 2.0? Our course is here for you. Learn at your own pace, all on our platform. In this course, you will dive into SAP HANA 2.0. Think of it as your go-to toolkit for managing supplies, ensuring we have what we need, where we need it. From the basics to advanced tips, we cover it all. Crafted by experts, you are in good hands. Your instructors, seasoned pros with heaps of experience. They are here to guide you and tackle any queries you might have. And guess what? Our students love it too. Just like you, they have found our course incredibly useful. And the best part? It's budget friendly. Learning doesn't have to cost a fortune. Ready to become a SAP HANA 2.0 whiz? Sign up today. For more details, head to ZaranTech's website.
Can anybody tell me, was SAP HANA a new invention by SAP company, or does it have a parent technology? Was there a product before SAP HANA from which SAP HANA was copied? Can anybody tell me? Perfect. Thanks, Vijayata. So we know that it was not a new invention. It was taken from the concept of BWA and it was extended. Perfect. Mike is absolutely right. Mike is referring to the Trex engine, which is similar to what Google engine has. And that was the parent technology which was leveraged to create the SAP HANA product. Now, we looked at how BWA was helping out organizations in the past and what was the challenges, right? So we saw that BWA had again duplication of data needed to take place, and then you had to constantly do the maintenance of BWA also, and we understood that it was not a sustainable product. So we SAP as a company moved into SAP HANA, SAP HANA, we understood that there are three different components or three different technologies that come together to make SAP HANA as powerful as it is. So can anybody tell me what technology takes care of your read functionality? There's a question from Mike. Let me quickly answer that. Is there a limit of database size on HANA? I think the latest I heard is you can go all the way up to 24 terabytes. A few years ago, I think it was the limitation was 12 terabytes. But now you can go for all the way up to 24 terabytes. But if you just think about it, right, Mike, a 24 terabytes on a HANA system can go a long way when compared to traditional databases with the similar amount of, because if you remember the compression factor, if you take that compression factor into consideration, you're almost talking about 100 terabyte worth of data can be stored within this 24 terabytes of data because of that compression capacity that's brought by the columnar technology. Okay. All right. So can anybody tell me what technology within SAP HANA takes care of your read performance? We understood that there were three different technologies that comes together to make SAP HANA. Which particular technology within SAP HANA takes care of read performance? It's the TREX engine. TREX stands for text retrieval and extraction. This takes care of your read performance. What takes care of your write performance? When I say write performance, the traditional relational database management system capability. Perfect. Thanks, Kofi. The write ability is taken care of by P star time. P star time, with the moment you think of P star time, think of any traditional database like SQL Server or Oracle. What it would do, that's exactly what P star time is doing. And we all know that because SAP HANA is an in-memory system, in-memory data always is volatile in nature. So in order to take care of the volatility, what is going to happen? SAP HANA brought in the third technology, which is to do backup exclusively only for backup. That is SAP Max DB. All right. Is everybody good with this information? We saw that the TREX engine, because traditional databases, we all understand that when it gets a transaction, it has to store that data into a table. That's what the P star type does. And backup is simply every time a data is stored inside the database. Let's say this is your memory. Some data is stored inside your memory. That memory data gets copied over automatically into your MaxDB database. That's all it is doing. There is no additional functionality. But what is a black box, or what is new to us, or what we don't understand completely is the TREX engine's capability. We saw that TREX engine's capability can be broadly categorized or broadly classified into three different sections. One is, we understood that it brings that difference between the row versus column storage. When we talk about row versus column storage, hopefully everybody is understanding what the differences are. Some of the high-level things that we did is, we understood that by storing information in column format rather than row format, you get increased performance, read performance. Because each individual column is treated as a table of its own, there is no need for special indexing in the system. No partition is required because the system itself will partition. Can anybody tell me what is the threshold? At what point does the system automatically do a partition of a table? Perfect. It's actually, everybody is giving it to me in gigabytes. I think you probably understood it, but you just quickly typed it. The answer is, Felix is right. It's 2 billion records, right? 2 billion records. But I understand that everybody went for the 2 billion. All right. And so these are the primary. And what was the other important capability that we got by going into a column storage? I was just referring to that a minute ago. Going back to Mike's question, how much storage what is the database size for a HANA system? Can you tell me what additional advantage. We talked about improved read performance. There is no need for you to do indexing. There is no need for you to do special partitioning. There is one inherent advantage that the columnar storage would provide you, which you would not get typically in a row format, which is compression. Why is it compression? Because if a column has the value for years stored, exactly. So if I have a column called year and it is storing unique entries of 2021, 2020, 2019, and things like that, if the data is repeating, the same data is repeating for millions and millions of records, in a traditional row-based system, it will store that value redundantly, hence occupying more space. But in a columnar technology like HANA, it will always only store the unique entries. So in this case, if there are 3 years of data, there will only be 3 entries in that particular table, in that particular column, hence getting a significant storage reduction. All right. So the next thing that we are going to be talking about is massive parallel processing. See, just talking about the row versus column storage itself should have given you a significant heads up as to HANA is a powerful system when compared to its competitors, right? Just by the fact that we are shifting from a row storage to a column storage, you can see that HANA can beat a traditional database like SQL Server or Oracle, which is in the market. But if that was not proof enough to show that SAP HANA is powerful, we will next be talking about the next two things, which is massive parallel processing, MPP, and push down mechanism. Let's talk about the massive parallel processing, MPP. Now, when we say that SAP HANA is a very powerful tool, its power is primarily got from its advanced technology. We said it has the TREX capability, it has the P star time capability, and it has the MaxDB capability. These are, if I were to say, the software advantages or advancements. Would you agree? Because this is some kind of an algorithm, right? The TREX engine is a software. It's an algorithm that is helping the system run as it is running. P star time is also a software which is making the traditional relational database system type of functionalities capable. And the MaxDB software is helping you capture the data from the memory and store it as backup. So would everybody agree that this is the software advancement we are talking about? On the contrary, just the software advancement alone is not going to make SAP HANA the most powerful tool or the most powerful platform. What they have done is they have also created hardware advancements. Hardware advancements. What do I mean by hardware advancements? Is the infrastructure that goes with your SAP HANA software also plays a very key important aspect. So when I say hardware, for people who are not familiar what I'm talking about, the other way to talk about is infrastructure. And I will oversimplify that also. Broadly, if I were to divide infrastructure into 3 major buckets: storage, database, and network. In order for a system to run, you will need certain infrastructure, right? What do I mean by in storage is the CPU, processing speed, and things like that. Database, we understand, is the in-memory database, HANA database. And the network, when I talk about network, I'm talking about fiber optics, switches, routers, and so on and so forth. So in order for you to set up an SAP HANA system, you not only just need your software things, you also need your corresponding infrastructure. Now, what is so big about this infrastructure? Why are we talking about this hardware? Is there is a key advancement when it comes to the storage infrastructure of your SAP HANA. What do I mean by that? Just to make it a little more clear, I'll simply say that if you buy a laptop or a computer or a desktop right now, if you go to a Best Buy or some place, Fry Electronics or some places, and you buy a laptop, what's going to happen is when you look at the configuration will typically say something like the system has a 1 terabyte hard disk. I'm just coming up with some numbers, okay? The system has a 1 terabyte hard disk. It has, let's say, 32 GB RAM, which is nothing but your memory, in memory. This is what your in memory is all about. And then what you will see is it will read something like this. It has a Quad Pro 2.6 gigahertz or something like that. What is this? Is nothing but your CPU speed. CPU stands for people who do not know what CPU is, Central Processing Unit. Essentially, it is the engine of any computer. What it is, why you need a central processing unit is, a central processing unit, if you request some information or you have to retrieve back some information from your computer, the CPU is responsible. The central processing unit, the heart of your computer, is responsible for making that communication happen and making that interaction happen and fetching the information for you. So how powerful is your CPU makes a big difference. So the quad here, so you would have heard dual core CPU or quad core CPU. What it means is, a dual core CPU means your computer is made up of two CPUs. There are CPU 1 and CPU 2. Essentially, it's giving you parallel operations capability. Let's assume that this is your computer and this computer has two CPUs helping you. There are multiple requests. You're sending a request 1 and you're sending a request 2 to your computer. You're saying that I want to search for a file. At the same time, I want to be able to delete a large file from the system, from your existing laptop. What will happen is, because there is a dual core or two CPUs available inside your system, the first request would go to one of the CPU and the second request will go to the other CPU, helping you run multiple operations in parallel. Does that make sense for everybody? Similarly, if you go for a Quad Pro CPU, instead of two CPUs, there are 4 CPUs now running in parallel. So what's going to happen? You now have 4 parallel operations that can run in parallel, making your processing speed much more faster. If your computer has this much, when you go look at your databases like traditional databases, you will see, if let's say, for example, a SQL Server or Oracle, if you take that, it will have multiple CPUs. And these multiple CPUs will have the parallel processing capability. But the difference that you see, or the hardware innovation you would see in an SAP HANA system, is a SAP HANA system contains multi-CPU, multi-core, multi-motherboard configuration. So what's going to happen is, there's going to be multiple CPUs. I'm talking about 10 or 12 CPUs. Each CPU will have multi-core. And each multi-core will support multiple motherboards. So imagine that there is cascading parallel operation that can happen within your HANA system. Now, let's assume that if you remember the table that we discussed yesterday, there was a year value, there was a customer field, product field, and amount field. 2021, 2021, 2020. Customer or country, country is US, India, and product ABC, 100, 200, and 50. Some numbers, right? If this was the table and I was writing a query, I want to know by year what was the highest sold product. So I want to know 3 information in this. I want to know by year highest sold product, which means I need information on the product. And of course, if I need to know what is the highest sold, I need to know the amount also. Now imagine because SAP HANA treats every column as individual table, how is this massive parallel processing going to help me? The year value will be passed to one core in the CPU. The product value could be sent to another CPU with another core within another motherboard. And the product, the amount information could go into another system. So there is humongous amount of parallel processing capabilities provided by this hardware innovation in SAP HANA, that the speed, not only just your row format versus column format is giving you speed, but if you include the hardware innovation that has gone into place within SAP HANA, they have increased the speed manyfold. So you might ask me, this all looks good, but is there any quantification? Is there any proof that this SAP HANA system is a powerful system? Yes. So you can go check it out. SAP HANA, so SAP company did a proof of concept. So what they did was they went to a company and they took an existing SAP ERP system which was running using a traditional Oracle system. They chose one of the largest table that they have. This table had about 45 billion records. Billion, not millions, 45 billion records. And what they did is they understood that there is an existing report which runs on top of this particular table. With the humongous complexity that report had, they got a baseline of how long it takes for you to run this report on top of this 45 billion record table. The results came back in about 67 minutes. After crunching all the numbers, everything, the system was able to bring back the information in 67 minutes. Again, this is something that really happened. After capturing the baseline, SAP said, let's do one thing. Let's take the same ERP system. Do not do anything different to that system. All I'm requesting is you change it, just that the underlying database has now become SAP HANA. That same table exists with that 45 billion records. And they said, now let's run this report on top of this table, which is now sitting in SAP HANA. The results came back in 13 seconds. So can you now see the difference between the performance of a traditional database versus what HANA was capable of doing? The possibility of bringing it back in 13 seconds was not just attributed to your column format, right? Column format gives you that big difference in improvement in performance. But the additional capabilities that the other components are bringing to your SAP HANA, which is your massive parallel processing, also made it possible for you to significantly or exponentially increase the performance of the system. Now, we understand that this massive parallel processing is really awesome when compared to the traditional databases. So can anybody give me this hardware innovation? If I wanted to go and buy this product called as SAP HANA, when I say I want to buy this system SAP HANA, I'm talking about both the software piece of it and the hardware piece of it. Naturally, the software can only be sold by SAP company. I'm hoping everybody agrees, right? No, Oracle cannot sell SAP HANA product. So if the software component is going to be sold by SAP, what SAP did was, because they wanted to keep that performance really high, they said, we will only allow certified hardware vendors to sell the associated hardware components. Now, the vendor list has grown significantly. But if you want to know the top tier hardware vendors who have been supporting SAP HANA to make it as powerful as it is today, to name a few, Intel. Intel company has been one of the pioneers in providing the necessary hardware capabilities. Cisco, Fujitsu, Dell, and HP. These are some of the primary companies that has been supporting the necessary hardware, which means that this multi-core, multi-CPU, multi-motherboard capability infrastructure that capability has been provided by these companies. So when you buy a product like SAP HANA, you have to make sure that the hardware is only purchased from a certified vendor. Otherwise, SAP, when they come and do a check to make sure you have installed it correctly, they will not approve the system. So it has to be bought only from a certified vendor. So is the concept of massive parallel processing making sense for everybody? How it is giving a boost to the already advanced technology that you have because of moving into columnar storage. The software capability that SAP HANA provided through Trex is now additionally supported with the hardware innovations through this massive parallel processing capability. So now we have two information. We understand the row versus column storage advancements. We understand. Mike has a question. Who owns hardware technology? So great question, Mike. If you can please bear with me for like few more minutes, I will talk about the third concept called as push down mechanism, and then I'm going to talk about the deployment strategy. When I talk about the deployment strategy, I'll explain who will own the technology and how the technology is going to be handled. All right, but that's a great question. That's a great segue to our next topic that we will be discussing. Is everybody clear about the massive parallel processing and row versus column storage? All right. So that being said, now we go to this another major advancement. Even now, if you are not convinced that SAP HANA has the capability to perform at a exponentially higher capability, I will give you one other complementing advancement that SAP HANA has that not many other traditional databases have. So let's understand, if I have an SAP ERP system, and let's assume that that particular system is being supported by a traditional database. Let's give it either a SQL or an Oracle database. Let's understand that this is how the current system is. And let's assume that I have a table in this particular system, and let's call that a sales table, just to give you an understanding of what we are talking about. I'll say invoice number, country, product, quantity, and amount. I'll quickly give a couple of rows so that invoice ID is 101, country is US, product is, let's say, A, quantity is 10, amount is $1,000, 102, US, B, 20, $2,000, 103, let's say India, C, 50, it's equivalent to, let's say, $400, something like that. I have a table here. Now, I have a report. The report, when it is seeking information about the sales table, it wants some additional calculation to be performed on the report. Let's say I want to know, for every transaction I have made, I want to know the respective tax percentage. How much tax am I going to be paying on this particular sale that I have paid? Okay, as a company, I want to know what is going to be the tax information. So the reason why you would not store a tax information in your table is, can anybody tell me why you would not store a tax calculation inside your sales table? Exactly. Mike is absolutely right. A tax is more of a dynamic value, right? Today, the tax could be 5%. Tomorrow, it can go to 10%. And between countries, the tax percentages could be different. So there are multiple combinations that can happen with tax. So what happens is, typically such calculations like tax and all that would always be done at the reporting level. When the report is asking for that information, it will calculate it on the fly. There's a concept of on the fly, which means that at the time the report is being run, the system will try to calculate the tax information and then send it out. Now, somebody has to make this calculation, right? Who is going to do that calculation? In a traditional world like SQL Server and Oracle, let's understand what's going to happen if this report is asking for this additional calculation. The moment report says that I need, when you're bringing me the sales information, calculate the tax and tell me what it is. Inherently, The databases are not created for doing calculation. No calculating abilities are given to a traditional database. So what is going to happen is the moment the report says, I want this information, and it passes the information to the SAP ERP system, this entire table's data is pushed up all the way to the application layer. Does everybody agree that this is the application layer? This is where the software resides. And this is your database layer. Would everybody agree? The database layer cannot understand or cannot do this calculation for you in the traditional world. So what it will do, it will push, if there are 100 million records in this table, it will push all those 100 million records to the application layer. Now tell me, is an application layer created to do calculation, or is it created to just present the information to you? Is it more of a presentation tool, or is it a heavy computing tool? How would you think of an application layer? Simply by the term itself, just the term application layer and things like that, you would hope that it is mainly used for just presentation, lightweight information to be presented to you in a nicer fashion. That's what you would expect. But what these traditional databases used to do is, because they could not calculate, they could not do heavyweight computation, they used to send the data back. Now imagine I am sending 100 million records into an application layer, which is supposed to be just doing presentation. I am making all the calculations happen at the application layer. Now, an application layer is bombarded with things that it's not supposed to be doing normally, and that calculation is sent out to the report. Once this information is provided to the report and the report is closed, all these calculations are done. The data gets pushed back to your database again. Now, can anybody tell me what is the inherent disadvantage in this process? Application layer processing is not correct. You should not be doing heavy processing in an application layer. But because the database is not capable of doing that functionality, the entire data is moved exactly. Mike is absolutely right. You're moving your data back and forth. Imagine moving 100 million records and billions of records up and down the system. That is a bottleneck, right? It's going to take a lot of processing power to be doing that. In addition to just the movement of data, you're now making a presentation layer do heavy computation and send the information to the report. So this is how a traditional database always works. But SAP HANA, what they did was, they said, because it is an extremely powerful tool with all these capabilities of my tricks engine, the P-star time and all that, and the hardware innovation capabilities I have using this massive parallel processing, it doesn't make sense for me to be pushing the data back and forth from SAP HANA to the application layer and vice versa. So what SAP HANA did was, they said, I will push down all the computation directly into the database itself. The database is built because of its software and hardware innovation capability. The same request, if it happens when the report asks for this information through your application layer, the tax computation is done directly at the HANA database layer. So you're avoiding that back and forth. This is avoided completely. All the calculation is done here, and just the result of the information alone is passed back to the application layer for your presentation purposes. Can everybody see how much processing and time is reduced by pushing down the mechanism of calculation down to the database layer itself? So this again is an additional complementing capability of SAP HANA that makes that powerful, the system, how powerful it is today. So any calculation that needs to be done will be directly done here inside your HANA database? There's a very good question, Mike. So when I talk about the HANA architecture, I will explain the concept of what capability within the database is making it. There are 5 different engines that is sitting inside the HANA database, Mike. If I talk about it now, you might probably not understand the entire context. So when I touch upon the HANA architecture, which will be in our next discussion, next topic, next session, I will go into those 5 different engines and explain how the push down mechanism is being worked out using those 5 engines. Okay, but just for now, give me the benefit of doubt and understand that there is an engine within the SAP HANA database that makes these push down calculations possible, unlike the traditional databases. Okay, so these are the 3 concepts. So if you look at it, row versus column storage, massive parallel processing, and push down mechanism. So a quick information for you is you will get at least 4 to 5 certification questions. If anybody is following this for certification, you will get at least 4 to 5 questions that are about the 3 main classification of your Trex engine. Questions about difference between when to use a row storage and when to use a column storage, the hardware innovation using this massive parallel processing, and how the push down mechanism is making a difference for SAP HANA. All right, so just a note for people who are following this information for certification also, just keep a track of that information. Is everybody clear as to what row versus column storage is doing, what massive parallel processing is doing, and what push down mechanism is doing? Can you give me a yes or no, please, before we move on to the next topic? All right. So now what we have done is, if you look at it, we started off with the SAP evolution, and then the SAP evolution kind of led the way for us to understand why SAP HANA. Multiple reasons. They didn't have any database of its own. They could not sustain BWA as a solution. That led to creating this product called as SAP HANA. Once we brought this SAP HANA as a product, we understood what is the technology behind SAP HANA, which is nothing but your Trex, P star time, and MaxDB. We understood the how concept, how the technology works. We went into details of how the Trex capability is working, both from a software advancement and from a hardware advancement capability. We also, in our first session, talked about the roadmap. When, if you all remember, SAP HANA started off in 2010. November of 2010 is when SAP HANA came into the market. And then in 2012, here it was just a sidecar implementation. Then it went on to support products like SAP BW on HANA. Then it moved on to supporting SAP ERP system, SAP ERP on HANA. And they realized the power of SAP HANA as a product. They said, okay, 2014-2015 timeline, they said, I'm going to revamp or recreate this ERP product, and I'm going to make it exclusively run only on SAP HANA. I cannot take an S4 system and make it run on an Oracle or a SQL Server database. So they called something as S4 HANA. S4 HANA did not, the naming convention did not start right away. It was called Simple Finance. They started off with finance piece of the ERP, and they created this with HANA. And 2015-2016 timeframe, from then on, everything has been on HANA. So S4 HANA, the old BW system is now called BW for HANA. The old CRM, customer relationship management system, if you remember, we talked about it during the evolution of SAP. It's nothing but the advanced complementing capability of your sales and distribution module. Now that has become C4 HANA. So everything running on HANA, and this is the evolving. So everything now, what has become is HANA has become the central core for any SAP product. Any SAP product that's coming into the market is only going to be supported by SAP HANA. All right. And that is the question about when, the roadmap. So we have seen this information. Now let's move on to the next topic, which is SAP HANA deployment strategy. At the initial level, it might sound like it's a very complex this thing that we are going to be discussing. If I were to put it in layman terms, where is this SAP HANA going to reside? The system called as SAP HANA, where is it going to reside? That's the question that we are trying to answer. Now, going forward, when I say SAP HANA system, in your mind as a SAP HANA person, as an SAP HANA consultant, I want you to start thinking of multiple objects. The moment I say SAP HANA system, or even when I say SAP HANA interchangeably, think that it is not just one piece. It has the software, which is nothing but your SAP HANA software, and it has your hardware. Always bundle them together and think of it. The moment I say SAP HANA going forward, think that there are two pieces to this box. It has software and hardware. When I say hardware, always the hardware is broadly categorized as storage, which is CPU and things like that. Your actual database, in-memory database, and your network. There are other things to it also, but I'm keeping it like the operating system and all that. So I'm just keeping it simple. Even less, if you want, we can also add the operating system. So the moment I say SAP HANA, please start thinking in this box approach. There is a hardware component and a software component to it. Now, the question of deployment strategy. I, as an organization, I have decided that I want to go by SAP HANA. Now, the question arises, again, this is a discussion that typically senior management is going to have when they are thinking of starting a project with SAP HANA. The senior leaders, like the senior directors and the vice presidents of the company, when they have to make decision on how to purchase this SAP HANA product and where to keep it, there are typically two approaches a company can take. The deployment strategy approach. This one is called on-premise. The second approach is called cloud. And I will explain what on-premise and cloud is, so you will have a better understanding. But if somebody is going, you're fortunate enough to start a project at an early stage where you are also part of this discussion. Here is where you can show your difference or your quality over the other candidates, because you now, as a HANA consultant, you can actually provide suggestions or strategy on how to deploy SAP HANA. By knowing this particular concept, deployment strategy, if you get to have this discussion with your senior management, you qualify yourself over the others, because not everybody would have an understanding of the deployment strategies and what to recommend. So what I'm going to teach now is the difference between an on-premise and cloud, and in what scenario would you choose on-premise and in what scenario you would use cloud. With this information, if you get to start a project where this discussion is happening, you will be in a position to contribute significant information. All right. So for those who don't even know what on-premise is all about, let me walk you through what it means. Let's assume that I'm a company. My company is called XYZ. Mike has a question. Is there a cost difference? Absolutely. There are multiple factors that we are going to consider in making a decision between on-premise and cloud option. So cost is absolutely one of the critical differentiating factor. All right. Let's assume that my company is called XYZ. It's based off in Houston, Texas. This is my headquarters. This is where my company is running. So the typical approach is the IT department of this company to run the multiple applications that we have. The IT company can have Oracle applications, can have SQL Server applications. It can have multiple. Just assume that there are so many different applications that are supporting this organization. So anytime I talk about a system has the software and the hardware aspect for it. Would everybody agree? Anytime we talk about a system or an application, there is going to be an application, a software component and a hardware component. Hardware is nothing but your infrastructure. So you need to have all your machines sitting in some place, that those machines have to be helping you to run these Oracle application and SQL Server app. In a traditional world, where would all the underlying infrastructure? So imagine you will need so many networking wires, so many different racks to support your Oracle application, your SQL Server application. This is going to occupy a lot of space, right, in your building. So what happens? Typically, an organization will stand up a building. They will build a building, and this building is where all your infrastructure objects will be stored. Your networks, your CPUs, your storage objects, everything will be stored in this particular building. And this building is referred to as data center. So typical approach by an organization is, an organization will have a data center building. When I say one data center, it need not be one building, but just understand the concept. A building where all your infrastructure needed to support your software applications in your organization are typically created and maintained in this building. When you have a building like data center supporting your infrastructure, imagine typically what happens is, if your organization is based off in Houston, typically your data center is going to be located somewhere in your Houston area itself. Let's assume that you have a big campus for the organization. Within the same campus, somewhere the data center is going to be located. That's why the name on premise. In the vicinity of your organization, the building will be raised to maintain your associated information technology infrastructure. So you might ask me, for people who are familiar with information technology, right, and who are familiar with the concept of data center and building, maintaining your infrastructure, you might ask me, wouldn't it be prudent to keep your data center in a different place than in the same on-premise, in the same location where your headquarters is? True. And the reason why the question arises is, let's say a natural disaster happens in Houston. Let's say, for example, a huge hurricane or some kind of earthquake or something, a natural disaster happens. Power or outage goes completely off in Houston area. If you have your data center building also in the same Houston area, this will also lose power, which means that nobody has access to any of your applications, because these applications are being supported by the infrastructure, right? If the underlying infrastructure is not available, if the database is not open for you, how will you access the data? So that is a possible question that can get asked. So what typically happens in a normal traditional organization is, you will have something called a primary data center, which is typically closer to your organization. Exactly. Felix is absolutely right. So this primary data center will have all my infrastructure closer to my office. So that's why the term on-premise. But to think about backup capability, and in case of disaster situation, you also want to keep another building with the same type of infrastructure elsewhere, far away. Let's assume that you can either put it in Chicago, Illinois, or you can even go all the way. Let's say you want to go to India and you want to keep your secondary database, so secondary data center, in a completely different location, with the hope that any disaster that's happening in one part of the world typically will not happen in the other part of the world at the same time. So you're trying to cover your base and make sure that, so what happens if Houston, the primary data center, becomes unavailable, automatically you are routed to the second data center. So this becomes the primary now, and you can continue to get the data from this particular system. Is it making sense as to what an on-premise system is? By a quick show of yes or no, please. It might be a new concept for a few people, but the understanding, I want you to understand what it means. Essentially, on-premise means buying the associated infrastructure. In the case of SAP HANA, we know that you just cannot live with the SAP software, which is the HANA system, but you also need its corresponding hardware, right? Like your network, your storage, your database, all these things are needed. Where will you keep that? Where will that underlying hardware or the infrastructure remain? Organizations typically would choose the data center, the on-premise data center. It will have all the same level of security and everything. Yes, it is exactly the same as your on-premise. It is still considered on-premise because you control that data center. You still have the complete authority over that data center. What should happen within that building? When should the lights go on? When should the fans turn on? All that control within that building is still yours. Just that the on-premise is a little bit extended. It's now gone to India, but still it is your data center. When it is your data center, it is still considered as on-premise. Okay. Raphael has a question. So whatever becomes the source in times of natural disaster becomes the primary. Exactly. Correct. So what happens is, the moment you switch from the primary to the secondary data center, the secondary data center now becomes the primary, until the primary center, which went down, comes back online. Is this different from a backup? It is significantly different in the sense that a backup is a daily operation that you do, right, Mike? Let's say, for example, I have a database. In my case of SAP HANA, I know it is a volatile system. I have to back up that information into the max DB. Correct. So if you're referring to the disaster recovery system, DR system, that's exactly what this is. That's exactly what we are explaining. Disaster recovery system, DR systems, are nothing but switching from your primary data center to your secondary data center. Absolutely. Okay. So is it making sense for everybody as to what an on-premise system is all about? What is the purpose of a max DB inside SAP HANA if we have a secondary data center? See, the point is, even in the secondary data center, so what if I have a SAP HANA system inside my organization? We understand that the associated infrastructure will have a max DB box, and whatever is in the in-memory is going to be stored into this particular max DB. Are you with me so far, Kofi? That's the initial thought process, right? If I had a HANA system, there is going to be an infrastructure for my max DB, and the in-memory data, whatever in-memory data is being collected, it is pushed away into my max DB. This max DB is now sitting in the primary data center. Let's assume that this data center went away. You still need the secondary data center also to have a max DB to be holding your backup data, right? If you did not have that, when this went down, your entire SAP system is gone. You have no backup of information because it is volatile in nature. You have lost all your information. So max DB is the infrastructure component within your data center building that's going to be keeping track of your backup. Okay, but the duplication of that max DB in two different data centers is just to make sure that If your primary building goes down, you have another copy of the Max DB sitting in another data center which can be tapped into. Does that make sense, Kofi? Perfect. All right. So this is the concept of on-premise. Now, when I started the discussion about the deployment strategy, I said the question is, where does HANA reside? That's the question. Now we are saying that it can either reside in an on-premise data center, or it can go sit in a cloud environment. Now we are still talking about on-premise data center. There's a question from Rafael. Let me quickly read that. How many database centers could an organization have? Typically, 2. A primary data center and a secondary data center. Some companies try to live with one data center, hoping that that data center itself is in a different location, so that the chances of the disaster happening in 2 different locations is reduced, right? But the typical approach of organizations are they will have 2 data centers, one primary, one secondary. All right. So now the question is, now you understand what an on-premise is. The question is, how are you going to get the SAP HANA system? So let me try to give you an analogy. So you can buy SAP HANA as an appliance, or you can do something called as TDI. Again, these are all certification questions. So please, if you're looking at certification, TDI stands for Tailored Data Center Integration. Tailored Data Center Integration, TDI. There are 2 approaches by which a company can go purchase the SAP HANA product. So let me explain what is the difference between a HANA appliance and a tailored data center integration. Now you're still in the on-premise scenario. So imagine that this is your data center. You have your infrastructure supporting your Oracle applications. You have your infrastructure supporting your SQL. Let's say these are all the Oracle infrastructure supporting the Oracle application. These are the infrastructure that's supporting your SQL application. Now you have decided as an organization to go ahead and buy the SAP HANA product. They're saying you can, if you do not have the expertise, if your infrastructure team does not have any knowledge about how to create the network, how to create the switches, how to create the storage, how to keep the database correctly intact, if they don't know anything about it, you can go buy HANA as an appliance, like a bundle. So imagine, just to give you an analogy of what we are talking about, you can go to a place and you can buy a washing machine. When you buy a washing machine, do you buy the rotating the rotating box in the middle of the washing machine separately, and do you buy the outer cover of the washing machine separately, and do you bring it home and then put it together? Is that how you would normally buy a washing machine? Or will you buy the entire box? The box called as the washing machine, you will just buy that. That comes with all the things that is already installed, pre-installed, and the software to support the washing machine is all bundled together. How do we typically buy a washing machine? It's the second approach, right? You buy the washing machine as a complete appliance, which means that the software that is needed to run the washing machine is already installed. The hardware that is needed to support the software of the washing machine is already pre-installed. It all comes as a bundle. The entire HANA system, which is now your software layer and your infrastructure, everything is bundled up, is pre-installed and ready to go. You can buy HANA as an appliance. So all you will have to do is they will bring this appliance and find an empty space within your data center and plug it there. Now you have the required infrastructure for SAP HANA. Does it make sense? Can you let me know by a quick yes or no what HANA appliance means? You can buy it as a bundled object. Everything comes within that. You say that I want a HANA system that has 4 terabytes capability. When you say that, they will say how much software information is required, what is the necessary infrastructure like the network and the CPU and the storage space that is required for you. Everything is bundled together and given to you as one box. Yeah, software is also pre-installed in that, Mike. So what happens is when you say that I want SAP HANA, the software part of it is installed on it, and then they will say, okay, you need so much CPU processing speed. So they will give you so many racks of CPU objects, and then how much ever wires do you need, for the fiber optics, they will provide all that information. How many switches do you need? How much database space? How much max DB backup capability do you want to have for this 4 terabyte system? All that is already pre-manufactured for you, and they will just bring it and install it inside your data center. That is what is called a HANA appliance. All you have to do is turn on the switch and you are ready to go. You are ready to start your SAP HANA product within the organization. Now, having said this, can anybody quickly tell me what is the advantage of this option? Naturally, you will see that you as a company have to do very little. Exactly, right? You're not bringing your infrastructure team to do the design and how to create the product. You are saving a significant amount of time statement to be able to have your own product in full. Correct. So you do not waste your resources to create this bundle. Somebody is doing it for you and they are bringing it into your. So that is the biggest advantage you get when you go with a HANA as an appliance. But on the contrary, can you tell me what is going to be the limitation? Can anybody think of any limitations with a bundled approach? You are limited from a scalability standpoint. What do I mean by scalability? If you had purchased your appliance, keeping in mind that you wanted to start with the 4 terabyte space, they've already bundled everything together and they've shipped it to your data center. As you install it, when you start putting it into the building, you realize that all of a sudden another department within your organization came to know about SAP HANA's capability. And they say, I also want to join this bandwagon. I also want to start using this SAP HANA. Automatically, the requirement of your SAP HANA system increased. So now you calculate that instead of 4 terabytes, I want 6 terabytes of space. This appliance is already bundled together. Now what happens? You cannot just freely, you cannot change the system configuration and say, I want to add 4 terabytes to. Correct. So Mike has a question. Do they offer scalability? They offer limited scalability because they know this is where they can make money, right? Both the hardware and the software people, they will say, I'm going to give you a 4 terabyte system with the capability of expansion to another terabyte. They will only keep a space available for one more extra terabyte to be added. So if you wanted 2 terabytes and the system can only expand to 1 additional terabyte, they will make you buy one more new appliance to add to this existing appliance. They will make you buy one more bundle of object and send it to your organization, right? So what happens? The scalability is completely limited. So when the scalability is limited, the flexibility is also limited, right? I cannot freely increase or decrease the terabyte space. I cannot just keep adding more fiber optics to this bundle. It comes with whatever it comes. You cannot make too much modification to that appliance. It is good for people, for organizations who have not ventured too much into this product, who are very new to this product. They don't have skill set within the infrastructure team to support a tool like HANA. In such cases, it becomes an advantage. Relatively quick, right? Because somebody is making it all bundled together and they're just shipping it to your organization's data center. Does that make sense for everybody? what HANA Appliance is doing to you. The advantages it's making, making this organization save time, and it is also relatively quick to install the product because it's already bundled together. You just need to connect the wires when it comes to your data center and turn on the switch on this particular system. But the negativity with the limitation with this product is you are controlled by what is given to you. You cannot explore it and you cannot modify the configuration of this bundle because it is limited in its configuration. There are a couple of questions. Mike has a question. Any idea how much money is involved here? Just an outside guess. In the multi-million dollar, it's typically multi-million dollar contracts, Mike. If you look at a terabyte of HANA system, I think it runs probably around $1.5 million or $2 million. Again, please don't quote me because SAP has a very weird licensing. Every company and every customer has a different value depending on how much products they have bought with the company and things like that. So please don't quote me on that number. But if you want a ballpark, typically every terabyte is about $1 million. Million and a half is what the typical approach is. Support is part of the limitation because support actually is a limitation if you think about it, right? Because right now I don't have the infrastructure team in place to support it. I have to scale up my infrastructure. I have to now hire resources who are now capable of working with this infrastructure if something goes wrong. So that's, I don't know if you want to call it as a limitation or it's probably an opportunity in this case where the company has to step up its game in understanding how this technology, because otherwise what is going to happen? You are going to rely on the vendor to provide you the support, in which case the expense is going to be even more higher, right? But I think that's a good thought process. So this is one approach. If you look at 2010 to 2012, in this time frame, the only way that you can, as an organization, purchase a SAP HANA was as an appliance. They did not even have any other choices. So what happens? You order the appliance, you tell what kind of a terabyte you want, and the bundle will appear in 4 or 5 weeks after you have submitted the purchase order and you've made the payment. It will come in typically within 4 to 8 weeks time, and they will come and install it in your data center. But this works out fine for companies which are newly investing in SAP product, right? If I am an organization, I've never used SAP as a product, it makes sense that I buy it as an appliance and get going with it. But if you take big companies like, let's say, GE, Pepsi, and all these big companies, right? The top 500 companies, they are invariably using some form of systems, SAP system. They might be running SAP system. They might be running Oracle systems. They might be running SQL Server systems. So they might have big presence of all these different applications, which means that they have a humongous data center and they have existing storage, existing CPUs, existing network, existing databases that is supporting SAP systems. Though it could be either supporting a HANA database or it could be supported by an Oracle database or SQL. But the company has infrastructure already in place. They have switches, they have fiber optics, they have network capabilities, they have CPU processing speed capabilities. All that is already available for supporting SAP systems, Oracle system, and let's say SQL Server system. They already have a lot of CPU space freely available sitting within the data center. They have a lot of networking fiber optics cables that are already available in their system that can be leveraged. And they have a lot of database capability that is available in the system. Let's assume that they had originally bought some HANA system. They also have some HANA database space available in the system. Now, companies like this, if they are constrained and they say that SAP says that you can only buy SAP HANA as an appliance, which means that you have to buy everything from us as a bundle. The companies like GE or Pepsi, they started complaining. They said, I have already invested so much money in my data center, and I already have a lot of free infrastructure that is freely available. I would rather use whatever is freely available in my data center and only buy that is extra that is needed. Of course, I would have to buy the software for the SAP HANA system, right? The license I have to buy, the software. But the underlying infrastructure is something that I could leverage what I already have freely available sitting in my data center. And only for the remaining things which I don't have, I can buy that from the vendors. So all these companies, big companies, which already had some form of SAP presence in their data center, they started complaining. So what happened is around 2012 timeframe, SAP said, we understand that many our companies are now seeing the presence of SAP big time. We want to become a little more flexible. We want to now start giving you another option in addition to the HANA appliance, which still SAP was promoting big time because they could make more money by selling an appliance. They said, we will give you this tailored data center integration ability. What it means is, if you have the infrastructure capable of supporting the SAP HANA system, whatever is needed to support the underlying HANA infrastructure, if you have it, you can tailor whatever is available within your data center and integrate it with the SAP HANA software. You can buy the software license from SAP and you integrate it with whatever CPU, whatever network, whatever switches you already have available in your data center. You can tailor integrate the software with the available infrastructure. But the one caveat they provided, SAP provided, was the infrastructure you use to support your SAP HANA software has to be from a certified vendor, which means that if you already have CPU and all this coming from an Intel or a Cisco or a Dell or HP or Fujitsu type of company, their hardware has been certified by SAP, right? Because if you remember, SAP HANA's biggest selling point is its performance. You don't want to take a high running software like SAP HANA and make it run on an engine which is extremely slow or a hardware which is extremely slow. So SAP put down their foot and said that I will allow you to do this tailored integration to leverage your infrastructure, provided you tell me, you guarantee that you will only use approved vendor to approved vendor's hardware product to combine it with the SAP HANA. Mike has a question. Older version of hardware, if I have any. Correct. So it can be an older version of your hardware, Mike, provided it is still within the compatible range and it is still approved by SAP, which means that it came from a certified vendor. If your hardware came from Intel, now Intel has to say certified. They have to come and inspect it and say, okay, even though it is an older version, it is still compatible to work with SAP HANA software, making sure there is no performance degradation. Got it? So somebody from the vendor company has to come and certify it. And they are the ones, only the certified people can make this installation happen. You cannot, in your organization, let's assume that 2 people in your infrastructure team are very excited about HANA coming into your organization. They go read a couple of books about how to integrate the hardware and they want to do the integration. SAP will not allow it. SAP will need an SAP certified infrastructure person, either coming from the SAP company or from the certified vendor, to come and do this work. Only if they approve it, you can do it. Your team can help, but the final approval and the confirmation has to be certified by the certified vendors or the SAP installers. Okay. So, but you can see that there is a big jump from going to an HANA appliance to a tailored data center integration. What could you think is an advantage? Can you see that cost savings is an advantage here? Perfect. Cost savings is one clear advantage, right? Because I'm leveraging some of my existing infrastructure. More flexibility. I have my own routers and my switches and my CPU. So tomorrow, if I have to scale up to a higher demand, I can scale it up. Or if I have to scale it down, I have the ability to do that. What are the limitations? Time taken. Would you think that the time taken to do the installation and integration is going to increase? Because now you have to individually piece things together. You're not given a bundle. You have to do everything on your own. Absolutely. The risk is high. Things can go wrong, and that can probably push the timeline of your project significantly. Felix is saying takes more space. To an extent, it could take more space, right? More space because it's not bundled together. You're now piecemealing everything. It's not going to be more efficient. That way, yes, it's going to take more space. Absolutely. But is that clear now? Is everybody understanding? If I decided to go with a on-premise scenario, I either get a HANA appliance or a tailored data center integration capability. Is everybody understanding what is the advantages and limitation on either side? Because these are the discussions when you go, if you can just imagine, right? When you go to an organization and the organization is deciding on which approach to take. How should we go about buying SAP HANA? You as a contractor, let's say you go as a contractor, you get the opportunity to have this discussion with the senior management team. Now you can ask all these questions. You can say, hey, you know what, before you make a decision on whether to go with HANA Appliance or something else, can you tell me what is in your data center? What kind of infrastructure do you have? How much of left behind free infrastructure is still available in your organization? You can ask all these questions. You can provide some thought process. You can say, these are the advantages and disadvantages in going with the HANA appliances. You will come to a point where scalability will become an issue. You can give all these kind of valid information and thoughts to the group, making it helpful for the organization to make a decision. All right. So that is about the on-premise situation. An on-premise can either have a HANA appliance or a tailored data center integration capability. Now, moving on to, so let's also look at the advantages and disadvantages of using an on-premise solution. Let's start with the advantages. Can anybody tell me what are the advantages of having my own data center and having my infrastructure? What do you think? Why would an organization? Perfect. Mike is saying control. I, as an organization, have total control over my infrastructure. I have my own security guards. I have my own things in place to control the infrastructure that is within the building. High security. Would everybody agree? I control the security of that data center. So the possibility of data getting lost or data getting hacked and things like that, security breach and all that will be privacy. Exactly right. Felix is absolutely right. So privacy is a big thing. And I, as the organization, control the maintenance of all the hardware. I have a control over the entire data center. I can say when things should be upgraded, when infrastructure should be upgraded, and what duration should it take. I have control over the total control, and I have my own resources, my own infrastructure people maintaining it. So these are some of the obvious advantages that I have. Can anybody think of any disadvantages or limitation going with an on-premise? So Felix is saying takes more space. Yes, your space occupied is more, which means that you have to, the cost is extremely high. Correct? Is that probably what you're referring to, Felix? Because it takes more space, you are now paying more if there is more square footage occupied in the building, you are now paying more for that space occupied. It is expensive. Obviously, because now you're paying for the building, you're paying for the infrastructure, you're paying for the resources who are supporting it. So the cost naturally increases. You need to have resources, absolutely, Mike. You need to have resources who are technically savvy to help that system, to provide support to that system. Right? Time taken to start the project increases. Would everybody agree? A typical timeline, this could vary, but what if you look at it, let's assume that in January of 2021, I put the purchase order to SAP HANA saying that I want to buy this SAP HANA appliance. I want to get started. 4 weeks will pass away just for the make sure that the invoice has been received, the payment has been made, and the order is placed. So let's say February of 2021, and then they will start configuring the necessary system you have asked for. So let's say March, April. So typically about 8 weeks time. It could be shorter, but let's be prudent of all the other things that's happening. So around 2020, April 2021, they are ready to ship it. It will come in May and they have to install everything. So when you start a project in January, it's practical around May is when everything will be installed and you can start working on the project. So the time duration, it takes like 4 to 5 months just for you to get your bundle available. Or even if you took the tailored data center integration approach, you have to, it will take even more longer time, right? Because now you have to get each individual pieces, put them together, so get it certified and things like that. So the biggest disadvantage is the time taken for the installation and to kickstart the project. Again, Anima has a good point, risk of natural disaster. Now you have to not only think about your primary data center, the same kind of infrastructure has to be made available in your secondary data center. Because what if a natural disaster happens and it strikes the primary data center, you have to switch to your secondary data center. Again, the cost increases, the expense increases. You have to now have resources supporting your data center in the secondary location and things like that. If I were to take from this, the biggest two advantages I will have. Mostly other things are looked at as a challenge or a limitation. The two things that I will have extreme control over is high security. For organizations that are financial in nature, for organizations that are heavily regulated by the government, when you talk about defense type of industry, these are all organizations, they have to keep their data extremely secure. I'm not saying that not the other industries don't have to keep their data secure, but I'm saying that they have obligation to keep the data secure. So in such cases, the biggest advantage of having an on-premise is to have that extreme security. And if you are an organization which is having a lot of projects happening at the same time, you don't want to start a project and 1 month down the line, somebody goes and upgrades the system. So what's happening is you also, so one is extreme high security, the other one is extreme high control over the maintenance of your infrastructure. These are two key items that you want to take from the advantages of an on-premise situation. High security, high control over your maintenance of your infrastructure. Does that make sense? By a quick show of yes or no, please. So these are the things that we want to be understanding when we talk about deployment strategy from a on-premise strategy. Now everybody understands, even within on-premise, you can either buy it as a bundle called HANA Appliance, or you can buy it as a tailored data center integration. Now, continuing our discussion on the deployment strategy, we have talked about on-premise. Let's understand what happens in the cloud environment. Cloud is nothing but it's just a fancy term, okay? In an on-premise, your company XYZ owns or rents its own data center building. It can either own or it can rent. It can pay rent to a building and have control over that building. And here is where all your infrastructure is going to be maintained, right? So that is, this data center building is a location that is either close to your organization or you know where exactly that location is, and you can drive to that place or maybe take a flight or go to that data center and do it. So you have control of that building completely. Cloud is nothing but it is also a building. When they say cloud, for people who are not familiar, I'm not trying to play it very simply, right? I'm not just trying. When they say cloud environment, it is not something that's living up in the sky. For some people, they still probably think that cloud means it's something that's living up in the sky. That's not the case. This is also a building. This is also a building which houses the infrastructure, the necessary hardware, components like storage, network, and CPU, and all that. But this building is controlled by some other organization. To name a few that you know, like companies like Amazon, companies like Microsoft, companies like Google. They will have humongous buildings. They will have humongous buildings across this world. Let's say across this globe, they might probably have data center buildings in like 200 different locations. They could have 10 in China. They could have 20 in India. They could have 50 in United States. They can have 20 in Canada. They can have some in the Middle East and things like that. So they would have data center building available across the globe in many places in the world. So the term cloud means that you are using an infrastructure that is owned by some other company and they have their own data center. You don't have any ownership on this building. So, and you have no control on this building. You only, if you say, I have rented these two infrastructure objects, you have only control, XYZ company has only control over these two infrastructure objects. You own the data, absolutely. You own whatever is happening in this infrastructure object that is provided to you. That is all what you have control over. There can be, in this particular building, let's assume that this building is like a 250,000 square feet building. Maybe 2,000 square feet of this building would be given to a company XYZ. Another 2,000 square feet of this would be given to another company called ABC, and so on and so forth. You have control over what's going on within this XYZ 2,000 square feet. And some other company has complete control over this particular square feet. That is what it is. Basically, you're renting a space within a building that is owned by some other company. Does that make sense? That's a very simple explanation of what a cloud is all about. Again, please don't get confused. That cloud means that it's not up in the sky. It is just a building which is being owned by some other organization. You are just renting a piece of infrastructure from there. Got it? So that's where you would have heard the terms like Amazon Web Services, AWS, Microsoft Azure, and Google Cloud Platform. Sorry, my Google, the moment I said something about Google, my phone picked up my voice. Sorry about that. So these are some of the companies that are providing you cloud solution. Now, cloud can be made available in multiple ways. you can have a public cloud, or you could have a private cloud. So these are information that is needed for you to understand if the company that you work for makes a decision to go into, explore into cloud. You need to know what are the different types of clouds available and what are the advantages and limitations of going to one over the other. A public cloud means nothing but, imagine that you have a big building by Amazon or Microsoft. They have partitioned the building into multiple uh, places. Let's say 2000 square feet, 2000 square feet, 2000, and let's say 5000 square feet. Your company has been given the space of this 2000, the infrastructure that is sitting here in this particular location. You are renting it from the cloud provider, let's assume Amazon or Microsoft. If this building is deemed as a public cloud solution, what it means is, if your company, let's say this is XYZ and this is a square feet infrastructure that is bought by renting by ABC, and there is another company, let's assume that ZZZ company is also renting some infrastructure. Let's assume that you are renting infrastructure to support SAP HANA, and ZZZ is also getting infrastructure support for SAP HANA system. Now, in a public cloud, what happens is, the term public, what it does is, it says, because this building is controlled by Amazon and Microsoft, Microsoft and Amazon has a contract with SAP to support all these infrastructure. So SAP will say, in order to show the latest and greatest with the infrastructure for SAP objects, we will go ahead and all the SAP infrastructure that you have, that you are supporting within your building, I will go ahead and upgrade them no matter what on a quarterly basis. I will go ahead and simply upgrade the infrastructure, because to keep my name SAP HANA product latest and greatest, I will always keep upgrading the infrastructure to keep up with the functionalities that I am increasing in my HANA software. So even though you are renting, you as a company XYZ is renting the space 2000 square feet and the infrastructure for supporting your SAP HANA, let's assume that your company is in XYZ Houston. You have HANA software and it is connected to this infrastructure. You have started a project. You're in the middle of a very critical project. You have created, developing your data provisioning, your data models, everything you have started working. But because you are in the public cloud, you have no control to say when my infrastructure should be upgraded. You don't want to upgrade your infrastructure while you're in the midst of a project, right? You want to have control. You want to find a downtime or a quiet time when the infrastructure should be upgraded. In a public cloud, when you sign the contract with the cloud offering company like Amazon and Microsoft, if it is a public cloud, they will put a very clear disclaimer saying that we won't even ask you for permission to upgrade the underlying infrastructure. When SAP says that it is time for you to upgrade, we will go ahead and upgrade the system. So you risk the chance of derailing your project or delaying your project, because whatever you have developed so far might become incompatible with the new technology that has been upgraded in your infrastructure. So there is a question from Mike. Can you share resources? Yes, if in a public cloud, you can also share resources. So what you can say is, if I am, let's say I am a utility company, XYZ is a utility company, and ABC is a retail company, like selling shoes and things like that. There is no apparent contradiction between these two companies, right? It's not like I'm regulated. I should not pass any information between the company XYZ and ABC. In such cases, you can probably have one big infrastructure that is being co-owned or co-rented by two different companies. Naturally, that won't happen. Is it technically possible? Yes. But companies will want to keep their own, even if it is in the public cloud, they want to keep a barrier between your company and some other company, right? But it's technically possible, Mike. Do you own this appliance or hardware or buy them? No, you don't own any of the infrastructure. You are only renting it from Amazon or Microsoft. They buy all the, that's why they have control over this upgrade capability. You're only renting it. You do not have any ownership authority over the infrastructure that is being supported by this public cloud. Okay, Kofi has a question. Is this at a cost to XYZ, ZZZ, or is it is on SAP? No. So what happens is, to rent this infrastructure, you might be paying, let's say, $5,000 per month. Just like you rent an apartment or a building, right? You pay for the rental agreement, how much ever you want. Sorry, pen was not writing. That's the amount you pay. And ZZZ company, depending on how much square footage they have rented and how much infrastructure they are using, they will be charged as per the amount of utilization they are doing. Okay, that's what is happening. So when you look at a public cloud, obvious advantage that we see is cost savings. Would everybody agree? Because I'm going, again, there are different types of cloud offering, Mike. So the general approach of a cloud option is pay-per use. Yes, based on subscription model, right? How much ever you use, you pay for that. That's exactly. But there is a little bit nuances. I'll get to it in a few minutes as to how you would differentiate what kind of payment option is available, what kind of things happen when you get into specific types of cloud usage. But to give you a quick answer, yes, pay-per use. That's true. So does everybody agree that the advantage is obviously cost saving? Because I'm going into a public cloud, it's like I'm just, instead of creating my own home theater system in my house and spending like $10,000 or $20,000 to get the best projector, to get the best projection screen, to get the best ergonomic seats and all that, that's going to be heavy cost, right? If I just go to a movie theater and go get a ticket and see the movie, I'm only spending like $10 or $20, and then I'm done with my usage. So that is how, if I could give an analogy, a public cloud is a cheaper form of cloud offering. There is huge cost savings. Again, as Mike mentioned, you just pay them, let's say, $1,000. I pay $1,000 monthly to just use the facilities. That's all. If I had bought all these products, infrastructure, and installed it, I would have probably paid like several $100,000. In this case, I'm just paying a monthly fee to keep my work happening. But what are the limitations with my public cloud? Security concerns. Would everybody agree? I don't know where this building is located. I don't know who is taking control of this particular space. So there is always this possibility or worry in my mind that, is my data secure? That's a constant thing that's going to be bothering the organization, because I don't know, because it's a public cloud, there is a high possibility some hacker could try to get into this infrastructure and pull the data out of the system. Though there are securities in place, that is always a big concern for organization. A defense industry like Lockheed Martin and companies like that, they will never go into a public cloud because they know that their data is so secured and so regulated, they cannot take the chance of putting it in a public cloud and hope and pray that it won't get breached, right? Security concern, absolutely correct. Lack of control. Absolutely no control over the infrastructure, because on a quarterly basis, they will just go ahead and upgrade the infrastructure. Exactly. Right. So Felix is absolute. Security concern is the privacy issue concern. So these are the major limitations you would see when it comes to a public cloud. Private cloud is very similar. Imagine you go to a place like Amazon or Microsoft. Again, you have building, and the building is segregated. Let's say this time there is 2000 again, 2000, 2000, 2000. And you went and rented, you as an organization XYZ, you went and rented the infrastructure. Now, the difference between the public cloud, if you paid $1,000 for your public cloud section, 2000 square feet, you will probably pay like $3,000 or $4,000 to maintain this private area, which means that there is a tight separation from this 2000 square feet to this 2000 square feet. Highly controlled. Not everybody can just go into this section of the building. So what happens? They have increased the security. Now you have higher control over the maintenance. What do I mean by that? In cases where you have privately rented a section of the infrastructure from this company called Amazon or Microsoft, now you are having control and you are dictating terms as to when the upgrades should happen. Amazon or Microsoft cannot just have an agreement with SAP and say every quarter I'm going to go ahead and upgrade. So now you have tighter control over the environment that is supporting your organization. With increased security and with increased control over the maintenance, what is the natural limitation we are going to have? Or what is the drawback we are going to have? We are going to see an increase in the cost. Mike has a question. Is this just access control physically? Not only physically, right? It will be highly controlled where your physical badge, you should have a tight control over who can get into that facility and things like that. But in addition to that, data security also. I'm talking about what kind of control you have over who can access that infrastructure. It's both physical control and the control over the infrastructure. Vijayata has a question. Can we switch from a public to a cloud to a private and vice versa? Yes, you can do that. If your public cloud and your private cloud are being supported by the same organization, right? Let's say I used to use Amazon's public cloud and I started feeling the pinch of security and the less flexibility in control over the upgrades. I can tell them I want to pay more, switch me to a private cloud. So they can do that for us. Okay, does that make sense for everybody? How about switching from cloud providers? Yes, you can do that also. You can also do that. There is going to be a little bit of migration work that needs to be done, right? Because now you're moving it from one cloud platform to another cloud platform. So you have to now have new contracts in place. You have to make sure that the same infrastructure is available. You copy over the data from the old infrastructure to the new infrastructure. There is typically some additional. Who does this move? It will typically be the company that you're moving into. If you're moving from Amazon to Microsoft, Microsoft will first have to understand through the contract, understand what is the existing infrastructure, how much CPUs were they giving you to support, how much data space they were giving you to support, what kind of network support they were providing. And then they will have to stand up that. They have to now find a location of about 2000 square feet within the Microsoft data center. And they have to stand up that kind of things. And then there will be some kind of a tool to port your data from the old infrastructure. So the new company, Microsoft, will have that technology to move the porting of data from one infrastructure to the other. Both the side of the companies will have it. Depending on who is getting the contract, they will probably charge for the migration functionality also. Got it? So These are the differences between your private cloud and public cloud, pay per use, right? If I were to quickly put a matrix, again, I am in no way an expert on everything about cloud, so please take it with a pinch of salt that I am talking from my experience, right? Again, there are cloud architects and cloud experienced for people who can probably talk about it in depth. I'm sharing my experience with you. When it comes to cloud, there are certain things that you have to consider before deciding what kind of a cloud do I want to go to. So the things that you want to look at are network, database, storage. These three, if I were to broadly classify them, are hardware. Then you have license and application. And then this is software. And then I have uh, software maintenance and hardware maintenance. If I were to classify this, I'll classify them as maintenance. So if I were to put a matrix around this, let me draw a real quick.
All right, let's test your knowledge. Here's a question for you. Which programming language is primarily used for developing applications on SAP HANA 2.0? Option A, Java. Option B, Python. Option C, SQL. Option D, ABAP. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck! Type the correct answer in the comment section. Hey there, ready to master SAP HANA 2.0? Our course is here for you. Learn at your own pace, all on our platform. In this course, you will dive into SAP HANA 2.0. Think of it as your go-to toolkit for managing supplies, ensuring we have what we need, where we need it. From the basics to advanced tips, we cover it all. Crafted by experts, you are in good hands. Your instructors, seasoned pros with heaps of experience. They are here to guide you and tackle any queries you might have. And guess what? Our students love it too. Just like you, they have found our course incredibly useful. And the best part? It's budget friendly. Learning doesn't have to cost a fortune. Ready to become a SAP HANA 2.0 whiz? Sign up today. For more details, head to ZaranTech's website.
So imagine when making a decision on your cloud approach, few things that you want to consider are, if I could broadly categorize them, hardware, software, and maintenance. What happens with my hardware? What happens with my software? What happens with my maintenance? The decision that you take on these three broader categories will help you steer you for one type of cloud versus another type. So the most prominent types of services provided in the cloud are, so going back to Mike's question, there are typically 3 or 4 flavors of cloud services that are offered. The most prominent one and most easier one is called software as a service, popularly known as SaaS. Has anybody heard this term, software as a service? By a quick show of yes or no, has anybody heard the term SaaS cloud? So that is one approach. There is infrastructure as a service, IaaS, platform as a service, PaaS, PaaS, and finally, managed cloud as a service. MCAS. There could be others also. These are the different types of offering. So when you go to a company like Amazon or Microsoft or Google, they will say, I have different flavors of support I can provide. Pick and tell me what kind of services you want. Do you want a software as a service? You want an infrastructure as a service, platform as a service, or a managed cloud as a service? What does it mean? When these terms are thrown at you, what does it really mean? When you go for a software as a service type of subscription model in the cloud, what you're essentially saying is, I don't want to own anything. You as a company, give me all the hardware capabilities. So let's say I go with Amazon. Amazon has to take care of my network. Amazon has to take care of my database. Storage has to take care of, the vendor has to take care of the storage. The vendor gets the license. The vendor gets the list of applications that I'm interested in. The vendor does the software maintenance. The vendor does the hardware maintenance. You just pay X amount of dollars and you start using the service. What could be an example of an application that we are using almost now, even more prominent after the COVID became even more prominent from last year? Can anybody think of a service that exactly? Felix is absolutely right. If you look at companies like Zoom or WebEx, are you buying anything from WebEx or Zoom company to use it on a daily basis? Did you install anything for Zoom or WebEx? Did you buy the hardware? Did you buy the software? Did you do anything? You're not doing anything. All you did was you went into their website, you signed up for an account, you pay X amount of dollars, let's say $20 or $30 per month, as an organization I'm talking. And you create a user ID and password and you're good to go. There is no other work that needs to be done. You don't have to worry about the network. You don't have to worry about the software. You don't have to worry about the maintenance of that software. Does that make sense? That is the easiest approach to a cloud. If you don't want to invest anything at all you want is a pure subscription model. So Mike, to answer your question, pay per use is exactly what you're referring to as software as a service model. All I care about is paying for, if I have 10 users, how much do you charge me for 10 users? That's all. I don't need to worry about any other information. But you are an organization, you have some kind of capability, but you want to leverage, you want to push some of the mundane work to the vendor like Amazon or Microsoft. You want to make them work. So what happens is, when you say infrastructure as a service, the name itself has the terminology. The vendor will be responsible to work on the hardware. They will bring the network, they will bring the database, they will bring the storage to help support your SAP HANA system. The vendor will not be responsible for getting the license and application. You have to, as the organization XYZ, you have to talk to SAP and buy the license and the list of application. If you're going to support SAP ERP on HANA, SAP BW on HANA, all the different applications and the respective licensing has to be purchased by you. The vendor will not get involved in the software discussion. So similarly, what will happen? Once you have bought this, the infrastructure will say, I am also not responsible for your software maintenance. I am only going to, because I'm dealing with hardware capability, I will maintain your hardware. Once I built the network, the vendor is now talking, I built the network, I built the database, I built the storage, I will also go ahead and maintain it. I had nothing to do with your software. I had nothing to do with the list of your application. So you better either do it yourself. The maintenance, the software maintenance, the software upgrade and all that, you can do it. But we will only do the underlying hardware functionality. Mike has a question. Does SAP has to examine the service provided for? Absolutely. So even if it is in the cloud, They will have authorized people to go and verify and confirm that they are still utilizing. Again, these companies are all very big companies, right? Amazon and Microsoft. So they have contracts with SAP saying that we will only use approved compatible hardware. So they cannot just go buy a cheaper hardware to support your requirement. So they have contracts with SAP also. But SAP will do a final walkthrough and make sure that everything is intact as per requirement. All right. So Amazon Web Services, Microsoft Azure, all these will fall in the infrastructure as a services, and also it will fall within the platform as a services. So a platform as a services is slightly different from your infrastructure as a services. They will support your hardware. You still have to buy the application and the licenses. But once you have bought the application and the licenses, they will support your software maintenance and your hardware maintenance. So the key difference here is that once the license and the applications are bought, they will charge you extra to support that software maintenance also, in addition to maintaining your hardware maintenance. So that's again, Amazon has both this capability of supporting your infrastructure as a service or platform as a service. Just that the variation is additional support being provided. A managed cloud is something like a totally private cloud. So these can all stay within the either the private cloud or the public cloud. Software as a service can happen in private or public. All these can happen. Managed cloud is only going to happen in a private, as the name itself gives away, right? It's a managed, tightly approach. So you will have everything. So if you look at it, just the license, purchasing the license, it's very similar to your platform as a service, but it is extremely controlled, which means that they will do everything for you as soon as you give them the licensing and the list of applications that you have purchased. They will completely take over, and it will be like an operations. It will seem as though they are part of your organization. They will have dedicated resources working in a tightly secured part of the building, completely supporting your platform. So places like, so SAP has its own managed cloud platform. What is that's called as SAP Cloud Platform, SCP. Cloud Platform is an example. Also, Amazon and Microsoft Azure and Google Platform, all of these have also managed. But as you go from the top to the bottom, you will naturally see that the cost is increasing. Would everybody agree? Software as a service typically happens for smaller products like your Microsoft, like your Zoom and your WebEx. So typically the cost of utilizing that service is going to be very minimal. Now, as you go from there to there, now you are spending money for supporting the hardware. You have to pay money to your infrastructure vendor. To maintain your hardware, you have to pay. In addition, you're now paying, you as an organization is paying for your software. So as you go down the list of options you have for cloud, the cost is going to increase. Does that make sense? Does this give a little bit of clarity on what the difference between an on-premise and cloud option is? And when you decide on going for an on-premise solution, what are the things you should consider? Do you want a HANA appliance, or do you want to go for a tailored data center integration? Or if you decide to go the route of cloud, first you have to decide whether you want to go with a private cloud or a public cloud. Deciding on what you want to do, then you choose the type of service that you want to use within the private or public cloud. Do you want to go for a SaaS option? You want to go for an infrastructure as a service, platform as a service, or a completely managed clouds as a service option? So these are some of the options that are available. Why is this information relevant for a HANA consultant? If you can imagine, if you go into the project in the early stages of the project and your company is having discussion, you can provide all these valuable information in that discussion. You can steer them to the right choices by asking the different types of questions that you have understood now. By asking these questions, you can help them steer or guide them in choosing the right approach. All right, does that make sense for everyone? Can you let me know by a quick yes or no, please? All right, so this is what I want to cover for today's session. In our next session, what we are going to do is, we are going to, now that you've heard me talk a lot, hopefully it was all informational, because these are things that you need to understand from a soft skills perspective, from a foundation perspective. Starting next week, I will take you into the look and feel of SAP HANA. How does the SAP HANA system look like? How would I access? You would access SAP HANA through a HANA Studio client, and you can also access HANA through a web integrated development environment. I'll show you both ways to access. When I access this, to jog your memory, I will create, just to give you a flavor of how the system works, I will create a simple HANA table, nothing fancy. I'll create it as a column table, and I will show you how to look for that information. And I will load some data. Just, you've not understood how to do loading and all that, but just to give you a perspective of what HANA is capable, I'll create a table, call it a column table, load some 5 or 6 records, and then I will show you how to convert that into a row table and vice versa. So that way, you will also understand how that row versus column format capability is happening within the system. Once you look at the look and feel of the system, I will go into another very, very important topic called HANA technical architecture. How does the system, when we talked about the push down mechanism, you asked me how does HANA do that when compared to the other traditional databases, right? We will talk about the HANA architecture, then we will talk about the different engines that are running inside, and you will get an understanding of what is happening. Basically, this HANA architecture is very, very critical for you to know, because it's under the hood scenario. You know that when you turn on the ignition of a car, the car starts running, but that is good for a layman who is driving the car. But for a mechanic, if you want to be an expert in being a car mechanic, you need to know what is happening behind the scenes. When you open the hood and go and look at the engine and the different machines that are interacting with each other, what happens when I turn on the ignition? What is going on behind the scene? That behind the scenes information about what will happen when you do something on HANA is explained in the HANA architecture. Once we complete the look and feel and the HANA architecture, we will be wrapping up the first category of information that we started off, the foundational block. The foundational block will be completed, and we will start off with the core technology, starting with data provisioning. All right? Perfect. All right. So hopefully the information is, is the pace good for everybody? I've probably spent a little longer time because these are the critical initial discussions we are having, right? I want to make sure that everybody is on the same page when we come out of this initial block called the foundational block. So that's why I'm making sure that I give you enough examples for you to understand and retain the information.
Hey there, ready to master SAP HANA 2.0? Our course is here for you. Learn at your own pace, all on our platform. In this course, you will dive into SAP HANA 2.0. Think of it as your go-to toolkit for managing supplies, ensuring we have what we need, where we need it. From the basics to advanced tips, we cover it all. Crafted by experts, you are in good hands. Your instructors, seasoned pros with heaps of experience. They are here to guide you and tackle any queries you might have. And guess what? Our students love it too. Just like you, they have found our course incredibly useful. And the best part? It's budget friendly. Learning doesn't have to cost a fortune. Ready to become a SAP HANA 2.0 whiz? Sign up today. For more details, head to ZaranTech's website.